How's the audio chat? It's good? Yeah, I'll run it next weekend. I'm running it next weekend for sure. Yeah. Go on my what is the sprint? Where does it say that? I'm gonna send the link if people want to book. I don't know how many slots are left, but okay. Just waiting for the first candidate to join. Give him a few minutes. Are you the first candidate? Alex, are you the first candidate? Hop on, man. No need to be worried. I'm not gonna grill you. Don't be nervous. You should be nervous for the real interview. Not the mock. I won't grill you. Alex, hop on. I got some easy questions. Or who's first? Is it actually you? Yeah, I work at Fang. Can't say where though. Yo, James, any you got a recruiter call tomorrow? Any last minute tips for a recruiter call? I just go in there and make sure you're prepared. You understand what the company does, maybe the role that any questions that you have for the recruiter about the process to show that you're interested, and yeah, get to know a little bit about the culture, because the only time I've seen people fail these recruiter calls is when they just come completely unprepared. So know a little bit about the company, a little bit about the culture, and just have some questions you want to ask them. Sound super interested too. Yeah, how did you feel a recruiter call? I failed the recruiter call at pretty sure. Yeah, I failed the recruiter call at Uber actually. No, I don't interview yet because I just started. I failed a recruiter call for Uber or something. And yeah, no, but the role was for distributed systems, and they're like, give me any experience, or just tell me how use or how let me what did they ask me? They're like, how good are you with distributed systems? I was like, what the kind of question is that? But a lot of my roles in the past weren't working on like distributed systems. A lot of them were product specific roles. So I don't know if I gave the answer they asked, and they just probably moved on. But I was like, that's kind of a dumb question. Like, with distributed systems, like whenever you work in any large company, you're the the system is super distributed. But maybe they're talking about like Kafka or HDFS. What do you say if you got no work experience with a technology they want, but you know about it? Just no work experience you want, but you know about it. I'll just say I haven't. I'll just say I haven't worked with it professionally, but if you worked on it with in a side project or a project, bring it up. That you or Alpha, what's up? But yeah, if you don't have work experience with it, you can't lie. But the best way, try to have a project at least in the technology that they're talking about. And if not, say that you did it in a class. And if not, just say you read about it. So yeah, the best way. So if they're asking you about specific technology, for sure the best thing to say is you've actually worked with it in your job. If you haven't, second best is worked on it in a project. Third best is you did it in school or something. Fourth best is you know about it, you've studied it, but you haven't done anything into it. And so that a lot of the times, if there's common technologies that I see online, if there's a lot of common technologies that people are recruiting for, I make sure to make projects in those technologies so that when I apply to those jobs, I have something to talk about. Yeah, exactly. What's a good score on CodeSignal? I don't know, maximal. Yeah, exactly. If you want to get into ML and if you want to get into ML and you're currently a SWE and they're asking you, "Oh, what experience do you have with TensorFlow?" Imagine you say, "Oh, I just read TensorFlow books." That's not going to lead anywhere. So you could say, "Oh, the best is obviously, oh, I've used TensorFlow at work to do a project like X project and this is what the project was." If you can't answer that, just the next best is, "Oh, I built this project using TensorFlow. The project achieves this." Make sense? Nice. Yeah, exactly. So that's also a good strategy that Alpha said is try to get work experience in your current role. So if I'm interested in AI and I'm just a product person working on product features mostly, I can try to branch off into a little bit AI with some of like maybe hop on the calls with the AI people and try to take work related to the AI team or like do work for the AI team maybe 25 to 30% of your time during your job. Yeah, that's pretty cool. Yo, who's who? Wait, let me message the guy if he's coming up. Let me message this guy. Email the guest. Let's see problems. Let's see what the if I graduate May 2025, can I still apply for new grad 2026? Yeah, you could probably apply for new grad 2026 if you still don't have a job. So if you have no work experience, you're still pretty much a new grad, and I would say you should be able to apply to those jobs. Okay, let's look at what happened in the weekly contest yesterday. Dude, I hate these like Bitwise ones. Why do they like the love the Bitwise ones? Yeah, I guess I just haven't really studied them. Let's see. Waiting for this guy to hop on. You're given two integer arrays prices and a strategy where prices I is the price of a given stock on the ith day. Strategy I represents a trading action on the ith day. Strategy I represents trading action on the ith day where -1 indicates buying 1 unit of stock, 0 indicates holding the stock, and 1 indicates selling one unit of the stock. Oh, you're really enjoying the zero tract? Aziz, what's up? You're also given an integer k and may perform at most one modification to the strategy. A modification consists of selecting exactly k consecutive elements in strategy. Set the first k divided by 2 elements. And perform at most one modification to strategy. A modification consists of selecting exactly k consecutive elements in strategy. Set the first k divided by 2 elements to 0. Okay. This is sort of like a caching problem. We might need to just be able to calculate that fast. The profit is defined by strategy times across all days. Return the maximum possible profit you can achieve. Okay. Man, there's a lot. Kind of makes sense. So let's look at the example. We're given prices. And k equals 2. So -1 means hold. Indicates buying 1. 0 indicates hold. Okay. So if k equals to 2, you're given an integer k and may perform at most one modification to strategy or consist of selling exactly k consecutive elements. Shabaj, long time. I've been watching sheets for a while. Was looking for sweet intern roles for 2026. Is there a specific lead code problem set you'd recommend, and what would you say the timeline is to apply? Thanks for tuning into my channel and supporting. I just made a video on this called, let's see. How's working at Meta? It's intense. It's busy, but it's survivable. So try out this list, the Peralta 75 list, and watch that video on summer 2026 internships. Also, other ones is Blind 75, Need Code 150. I like my list more though. AWS? Yeah, AWS got you working the weekend? That's actually insane. How do they force you to work on the weekend? Is they just give you too much of a workload? And then you can't, you just have to work the weekend in order to hit it? Or is it just because the on-call? I used to work on the weekends, but that was voluntarily. Would you say graphs and DP are not as important, or would you recommend some not? Graphs are very important. You should definitely know graphs if you're trying to pass any interview. Dynamic programming is still very important, but you probably won't be asked dynamic programming. Hell no, Shilaj. So what do we do here? I think return the maximal profit. So I think all we need to do is so we need to figure out the total profit if we just follow all the rules. And then we do a sliding window. Find the total profit if we follow the strategy. And then 2, if we know the strategy, find the total profit if we follow the strategy. 2 would be, no, I don't do code forces, but I'm down. Should I try it out? 2 sliding window to figure out. But how would we do that fast? What's K? K is even. Oh, K is even is kind of... Select exactly K consecutive elements. Set the first K, hold it. Set the last to sell. What happens if... What happens if you try to sell but you don't have a stock? Okay, profit. You buy, you hold, and you sell. And the price is 8. Okay. If you select K, this is a good question. If you select K, you should basically flip K consecutive elements the first half. I'm just trying to see how you could do that fast. And what clarifications? I think the dude's about to join though. Jack, what's up? Hello? What's up? What's up?
Yeah, can you hear me okay?
Yeah, yeah, yeah. How you doing?
Okay, my bad. Yeah, I was
No
playing
problem.
golf and came back
Nice.
later than I thought. So,
No problem, man. No problem at all.
too late.
How's golfing?
It's pretty fun. I mean, I've been getting into it
Yeah,
past couple months. Not the best, but just
yeah.
went what with my brother and my dad. But
Sick. Have you hopped on here before? Like, did a coding interview with me or no? First time?
yeah, no, I think I did one a little bit ago. I think I did
Alright.
one a little bit ago. I don't know exactly when, but
What did I ask you?
um, I think diameter. You asked me diameter of tree, of binary tree.
Did you get it?
Yeah, and then you asked me. I actually forgot the second one you asked me. I'm not gonna lie, but.
Were you able to solve it?
Yeah, I think I was able to solve it like barely, just like
I
I
see.
barely solved it with all the time, but yeah.
Okay, I have some. Okay. Okay, I'm just gonna start this up. You ready? Right after golfing, just hop straight in.
Yeah, I mean, I guess so, yeah.
Alright, okay, I'm gonna start up this. Hey everyone, so today we have somebody joining in from Missouri, currently works at a bank, has solved 250 lead code questions. We're gonna hop in for a coding interview. Are you already graduated or you're still in school?
I'm still in school right now.
Oh
I'm in my
really?
last
Nice.
year.
You're
Yeah.
in your last year?
Yeah.
So you graduate summer 2026?
I'm graduating late, so I guess it's supposed to be my last year, but it's not gonna be my last year because I switched majors. So
Okay.
yeah,
Are you ready to graduate or you still haven't or you started applying already?
yeah. I mean, I'm still applying an internship because I'm gonna graduate like December 2026. So
Yeah.
yeah, I've been applying. I've been applying.
Yeah. All of the stuff are coming out, so you have to get on that ASAP.
Right.
Cool. I sent you the link.
Okay. Let me log in. Um, Hold up. Okay, I don't know why this is not working. Give me one sec. All right, I think I'm in.
Okay, wait, give me a sec.
Can you see what I'm typing?
Yeah.
All right, bet.
Just, let me verify my stream. One sec.
Okay.
All right. We're just gonna get straight into it. What we're gonna be doing is we're gonna be building a task management system. This is gonna be a bit more practical, but
Okay.
this is the what programming language you like to code in?
I'll say Python.
Python. All right.
Yeah.
So we're gonna be building a task management system where we're gonna be able to put tasks into the system and then also specify if a task has a dependency, and the task needs to have a dependency to another task essentially, but that's optional. So the first part, we're gonna have multiple parts to this question, is implement a system that could where you could add task and then add a dependency between that task to another task.
Okay. 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 I guess. Okay. I guess. Okay, I understand like adding the new task. It's just you have.
Yeah, and this is a
That's
coding interview, by the way. Like we want working code, and we're gonna run it to make sure.
right. Right. Um. Okay. So adding new tasks. I don't know how exactly I'm gonna do that, but um, can you what exactly like is a task? Is there like attributes in what a task should be, or is it you just want me to
What
like
do you
how
think? Like
exactly?
what do we how do we want to store the task? Basically, the task
Yeah.
just needs to have a name and a specific like description.
Okay, just like a name and a
Like
description.
instructions, a name and instructions.
Okay. So
Or let's just say it's a name. It's like a to-do list. You just all it has is a name.
okay, just a name.
Yeah.
Okay. Yeah, I mean, I guess just in case there's more complexity later for what a task is, like I'll create like a small class for a task, and then I'll create a class like called task management to kind of maintain like all the task objects that we have.
Mm-hmm.
So like and then adding new tasks, we can just add it. Here, let me think about how we're. I mean, you could just do it in a list, but it's probably not that good. I guess my question is, can you explain what add dependencies between tasks mean? Does that just mean like one task happens before another task? Like, is it all in like one line, or can like multiple tasks rely on like the
I
same
mean, yeah.
task? If that makes
What I would say is you get to figure out the design for the class, but we just want to add task and be able to add dependency between tasks. So for example, I say, oh, I want to work on my assignment, right?
yeah,
I could create a
yeah,
task where I want to work on my assignment, and I can create a task called research my assignment or eat breakfast, and that task is a dependence. Like I want to do that task
yeah.
before
Okay,
I
so just
start working on like my actual
okay,
or start working
okay.
on my assignment. Yeah,
So I'm assuming like any task can have X amount of dependencies, essentially.
just one dependency.
Oh, it's just one
Yeah,
dependency. Okay,
for now.
for now. Oh, well, I guess I'm gonna just make it. So yeah, if there's only one dependency, we could just like have like a map, right? That maps like the dependency to like whatever the task is, right? So like dependency of task and then map it to the task, in like a hash map of some sort. And I'm assuming the dependency of a task is also obviously a task, so it would just be like a task object to a task object.
Hmm.
Um, and then in terms of adding new tasks, um, let me think of how we want to store it. I guess we just put it in like a list for right now because we don't necessarily have to do, I guess, too much computation with it. So I'll just like put it in a list for right now. Um, putting storing the object, the task object in a list. Okay, yeah. So this is like kind of, I guess, roughly what I'm gonna go off of. Does
Hmm.
this make sense?
Yeah, that makes sense.
Reasonable. Okay. So yeah, I'm gonna just go ahead and so we'll do class task. So we'll do name. Okay, we'll do that. Just like a quick task class, and then we'll have like our task manager. Um, and I guess we're not necessarily starting with anything. I'm just gonna like create the skeleton first. So we'll do like def add task. I'm assuming it's gonna be like self, and then um, task, and then the other function of like add dependency.
Nice.
So we'll do self of. I'm assuming we're gonna input like dependency and then the task itself, right? So something like that.
Sure.
Um, okay, so yeah, just to go in and implement it, obviously we want to add our task. So let's make like a list for that. So we'll do self current tasks, and then we'll just quickly implement this. We'll just append it at the end for right now. Self.current task, append, I guess, task. I guess this is assuming that, like, should I assume that they're gonna be using our class? Not necessarily. Like, should I just be like, you would input like a name and then I would create the class task object and then put it inside. Like, what do
Yeah,
you?
they're gonna be you define the API that they're gonna be using. So if it's gonna be a task manager API and then they
Yeah,
add tasks, that works.
yeah. So we'll just do like a name and then we'll create kind of the task object for them per se.
Sure.
So
Yeah,
do like
that's
current.
fine.
We'll do like, shoot. What am I gonna do for name? Okay, I'll do task equals task and then name self current task dot append task. Okay, just do that. Dependency name I guess for the add dependency, we want it to. I guess it would be weird to actually no. We can just do this. We'll just do this. I don't know if this is the best way of doing it, but let's keep it uniform. So we'll do dependency task equals task, and then task equals. Then we need to make like some type of dependency graph, right? Or like dependency map. So we'll do task equals.
What if the dependency is already in there? Pretend I already created a task called like um, go walk the dog, and then one called eat dinner, and then later I want to attach the dependency.
Sorry. So you're saying like if the dependency was already inside of it, you
Yeah, I'm
wouldn't want to
saying.
be able to like.
Well, it
Yeah.
depends. It depends on how we want to handle it. I'm just asking that now because I'm just looking at the code.
Okay. Okay.
Like
Yeah.
right now, you're assuming that the task dependency doesn't exist already. I mean, we can make that assumption. I would just write it down.
Yeah. So yeah. Well, I think for right now we're just assuming like, I guess assuming that dependency is not there, and that like we're not gonna override it per se. Like if it's already in it, like we're like you said, there should only be one dependency for one task, right? So given the fact that like you won't just change the dependency of the dependency to the task, like that relation, as long as you don't change it, it doesn't quite matter like how many times you would add it, right?
Sure.
So I feel like we go with this assumption. But yeah, I think that's technically.
Okay.
Oh wait, shoot! I don't know why I put this up here. Okay.
So, all right. Okay. So walk me through the code.
Yeah, so we have our task manager class. It has kind of two data structures, a map to encompass like all the tasks. I guess I'm also assuming that we're not like putting in the same task again. I could probably like make it a set or some sort. But yeah, so we have two data structures, one with current task, one with the dependency map. And our function will add the task, which basically just makes the task object out of the input name and then just appends it to the list. And then the add dependency function will get our dependency name, task, and then the name of the task that it's like pointing to per se. And then we're just going to create task objects out of both of them and then store it inside of our map.
Okay. Can you write me a function that prints out all the tasks and each task dependencies?
Okay, so print out all the tasks and its dependencies. Okay. Here, let's think here. Yeah, so right now we have our thing kind of as the dependency to our task, more so than our task to the dependency. I feel like maybe let me see. I think for right now I'm just gonna keep this here, but I'll do something like this. So I'll do dependency to task just in case like we need this later, you know. But I'll just do self dot task to dependency, and we'll just like kind of rewrite it, right? So we'll do something like this. Shoot, I can't spell. Okay, so something like this. So that way we have like a map with already all the tasks, right? With all the dependencies and tasks. I guess we can't necessarily just go through our task to dependency list because there's a scenario where you have a task but it doesn't necessarily have a dependency to it, right? Or can we make that assumption that every task has at least one dependency?
Well, what if it does? Like, does that matter if it doesn't have any dependencies?
Yeah, because if it doesn't, like, if we can assume that, then we could just go through our tasted dependency, given the fact that we would have already added all the dependencies. Oh, actually, no. Never mind. Basically, sorry, scratch what I just said there.
Hmm.
What we'll do is we'll just go through our current tasks, right? So obviously, we're only going to print out all the tasks that they've already added, right? They have to add the tasks first. So we'll just go through the self.current task and then just check if it's in our map of the dependencies. If it's not there, we'll um yeah, if it's not there, we'll just print like nothing or just have a blank spot. And then if there is dependencies, we can just
Yeah,
kind of display those that way.
makes sense.
Okay.
Yeah,
So I'll just make
like
that.
if it doesn't have a, when I say print out all the tasks and its dependencies, print out the task regardless if it has a dependency or not. But if it does have a dependency, tell me the dependency. So
Right.
it should be like task and then maybe like a list. Well, we said we didn't have multiple dependencies yet, but the task and the list of the dependencies. Empty if it has no dependencies, and just one element if it has a dependency.
Yeah, and you said you wanted me to like print this, right? Like into
Yeah,
the
print it
console.
to the console.
Okay. All right, sounds good. So yeah, since it's like we're not necessarily getting an input here because you're just printing everything. So we'll just do like for I guess task and task. We'll say if the task is in the self.task to dependency, then we'll have to print that dependency out. I guess, is there a specific way you want me to format the print? Like, is it okay if I just like put it one after the other, or is it?
Like, what are you thinking? You could propose what you want.
Oh,
I mean, it
okay.
could just be like task one, like this. Task two,
Yeah.
task
Okay.
one.
Yeah. Yeah. Okay. That's what I was thinking. Um. Okay. So we'll do. So here we'll say dependency right now. We'll just have like a blank. Or here, let me see. Um. Yeah. We'll we'll just make that blank, right? And then if we have something, then we'll set it to the dependency dot name because we want it to probably be a string or inside. So we'll do something like this. So if it's inside of it, we're gonna go to the dependency and then we're gonna look at the dot name because it's like in a class task wrapper, right? And then now we just want to kind of like print it out. So we'll do print. I think it's F. Actually, don't. Where is it? Wait, do you put it in here? Yeah. Okay. So we'll do print task.name and then we'll just like put a colon space there and then like put dependency. So like something like that. And I think let me see if there's any issues with that. Yeah, I'm gonna just put that there. All right, yeah. Does this look reasonable?
Yeah, write some test cases, and let's see if
Okay.
it works.
Okay. So we'll just create our task manager object. And then we'll do we'll do dot add task, cook food, something like that. And then we'll also add task manager. We'll do like clean dishes. So let's just say like you have to clean the dishes before you cook the food, or actually let's just say cook and then clean. So let's like add that dependency and then we'll just check the print.
Yep.
So we'll do dependency of doing the clean dishes and then cook food.
What's the relationship we're establishing? What's the first parameter and the second?
Sorry, yeah, the first one is the dependency, and then the second one is the name. So
Okay.
I'm saying, actually, let's make the relationship clean dishes and then cook food. I feel like that's a little bit more intuitive. Like,
Clean
assuming that you
you
already
clean
have
the
dirty dishes.
dishes, then you cook the food.
Yeah, clean the dirty dishes and then cook food.
Yeah, that's
Actually,
no. You should cook food before you do the dishes, right?
oh no, yeah, I mean, I guess, yeah. I don't know why I thought of it the other way. Okay, yeah. So cook food and then clean dishes.
Yeah.
All right. That probably okay. That makes sense. And then we want to do the print something like that. So I'm hoping this will work. I can try running it.
Yeah, right.
Oh, oh shoot. Um. Okay. So obviously the dependency is not there, unfortunately. Um. Here, let me see. So self dot dependency to task, and we set it to this too. Hmm. I guess I'm confused. I'll just print this really quick. Obj dot. Oh, okay, that's not very helpful. Here, let me think. So I mean, it looks like we have a task to a task. Self dot cur task. If task is so dependency. Um. Um. Wait. Okay, so dependency equals the self dot task to dependency dot name. Print f task dot name.
Mm-hmm.
Shoot, there's probably something stupid, but I can't really tell. Task. Okay, is it okay if I use some print statements here?
Yeah. Go ahead.
Okay.
Print your way. Print your way till you can debug it.
Okay. So let's just literally look inside. Is it not there? Oh shoot. Okay, I'm good. Oh. Wait, but this should append the task. Okay.
Yeah, that's working all good.
So self.task. Oh, I don't know. Task manager. Okay. Task to dependency. Oh shoot, I think it's spelled wrong. Depend. Shoot, why can I not spell? Okay. Let's rerun it. Okay, it's a key error. So I guess it's not saving it properly. Uh, Clean dishes. Shoot, is this not happening right here? Is this line 44?
You printed out the map, dude. The map exists.
Yeah, the map does exist. Wait, I don't know why I'm tripping. Hold up. Yeah, so I'm just like putting the key in wrong. Oh, wait, but this is the task object, right?
Yeah, it's a task object.
So I'm indexing in and checking if the task object is in the task.dependency. And if it's inside it. So I'm assuming obviously it's not going inside here whenever it runs. Oh wait, let me take that out. Yeah. What? Oh, I guess maybe it just doesn't read it to be the same thing. Like whenever you.
Okay, let's take a look. So you're able to create this task dependency, but when you try to see if a task is in that list, it's returning false. So it's never getting
Yeah.
in here, right? So could you
Yeah.
just why do you think that it's not showing in the dictionary? Like why does that key not exist in the dictionary? Like what are some possibilities?
I guess like whenever you make the task here, it doesn't necessarily relate to like you could create like two separate instances of the same task object, but it's like different objects.
Yeah, there's gonna be different objects, right? Because when you create the dependency here, ta- task dependency.
Yeah. Okay, I don't know why I didn't think of that. Okay, yeah, so they're basically like I'm making two different task objects every time, basically, instead of like saving it or like using. So like this is it. Like you could add a task with a certain name, and then make a new object. But then whenever you also index through and add the dependency, you're making a different instance of that object, but with the same data, but it's like a different object.
Mm-hmm.
That's why it's not showing up. So basically, I guess it was my fault for kind of even making a class there. I probably could just named it a name, but basically like to solve that, we could just kind of put like a name to task thing. So we'll just do like we'll do something like that so that it can whenever we add the dependency to it, assuming that we had already added it into the name to task, it would just reference the same thing whenever we put it in the dictionary. So we'll do
Name to task.
ask object. Yeah, we could do something like that. So yeah, that now it should reference the same one when we add the dependencies. Yeah, there we go. Okay, yeah, I don't know, just blanked right there.
Okay, let's see. Cook food. Clean dishes. Okay. So pretend I wanted to. That's part one. Let me write down
Yeah,
part two. So write a cycle or write a function that
yeah,
determines if it's possible to do all of the tasks.
Okay.
What do you think? How would we solve that?
Yeah, I mean, if you wanted to, I guess, let me think. So doing all of the tasks. I guess you would just have to make sure that, wait, hold up. Wait, so I have a question. Can I assume that all of these tasks like will be connected? Like it'll be task 1, task 2, task 3, or can there be like task 4 here?
It won't be connected. People just could put random tasks and random dependencies, and we
Okay,
just
so
need
it
to
can be like
verify.
that. Yeah.
Yeah, someone could just put task 1,000, or
Oh, okay, okay.
like, or like, there's not really a number to a task, even with your code. It's just a name. So they could just have a bunch of different tasks and then different dependencies, and we just need to know if it's even possible to do all these tasks.
Right. Um, so I guess the only way it's like not possible to do like all these tasks is if so you do. I guess if like you if task 3 is like a dependency to like task 1 per se, or like task 3 is a dependency to task 2 or something like that. Because if you don't if you have everything like this, then obviously you can just do it in order and do it, right? For any of these, regardless of how many tasks you have, as long as it's like all in the same order. But if you basically if task 2 depends on something, like if task 2 depends on task 3, for example, then it would be like messed up, right? Because here task 2 needs to be done to do task 3, but
Your
then
phone is
if
tweaking.
task 3 needs to be done for task 2, then like you wouldn't be
Task
able to do
one.
it.
Yeah. So you're saying if there's a cycle at all?
Exactly. Like if there's like if there's some sort of cycle, would be like the only limitation per se, right? Um, is the let me turn on do not disturb. Okay, there we go. Okay, yeah. So any sort of cycle is gonna be like how we won't be able to do it. So let's like create something that can essentially do that. Um, I guess a way that we could do this like pretty efficiently, I think, is we could do like a topological sort of some sort, right? Where we have like pre we have all the prerequisites. Like we already have like a prerequisite, a dependency to task type of thing right now. We could go through all of these and essentially start with the ones that have zero dependencies, right? So we'll start with like task 1, task 4, and task 5. And basically those you can do without anything, right? That's kind of the definition of it. And then one by one you would like take it out, right? So task 1, um, we're able to do it, so we're going to add it to a list to where we can do it, and then we're going to go to task 2. All right, does task 2 have any more dependencies that we need, that are not that it like if task 2 basically drops to 0, then we should be able to do task 2. If task 3 drops to 0 after doing task 2, then we should be able to do task 3. But I guess in the case where it's like task 3 also needs task 2, I guess you'll go to task 1. Task 2 will still have, I guess, here it'll be something like this. Task 1 will be done, but then task 2 will never be able to take it out, essentially, right? Because it will have this task 3 dependency that it can never get to. So at the end of like our sort, basically, we're not going to be able to reach like all the tasks that we have. So we'll just check like if it reaches the same, like if it has the same number of current tasks, assuming that we don't have any duplicate tasks in our add task, right? Um, so yeah, does that make sense?
Yeah. Okay. Let's see. So how would you implement sort of a topological sort? Maybe we could just talk about it real
Yeah,
quick.
yeah. Okay, yeah.
So
So
like
we would
pretend we
have
have the task. 'Cause, yeah, we only have a few minutes.
okay, yeah. Since we only have a few minutes, we'll quickly first create like an in degree list, right? In degree list for all the nodes. And this is basically any of the like tasks that have like a dependency on it. And we'll have like a queue of some sort, right? I'm gonna do like topological sort, kind of like I guess the BFS, or I think it's called the cons algorithm, but um, we'll add essentially all the ones that have zero add all the ones with 0 dependency on it. And then basically we're going to go through each one and just check, right? Like, boom, we're able to do it,
Mm-hmm.
right? So we'll do like something like a while the queue is there. We'll do like for all the, here, let me think, dependency to, yeah, the dependency like to task. Or I guess are we only assuming that there's one? If it's just one, then it would just be like you decrement the dependency to task. If there's more than one, we'll go through that list of what the dependency is. So we'll do like something like that. So task equals queue.pop left. So we'll do for all and then decrement the dependency or like the in degree list per se. If it reaches 0, then we'll add it to the queue. And then it will just like keep on going on from there, right? And then obviously we have to keep track of like lists. So we'll have like a number of like num task completed equals like 0 at the beginning.
Yeah.
And then we'll increment that number here. Again, we'll only be able to put stuff in the queue if it reaches 0, right? But if there's a cycle, it will never be able to reach 0. So basically, if like and then at the end after doing all this computation, like if the num task completed equals the total number of tasks, return true, else false, something like that.
Mm-hmm.
Does that make sense?
Yeah, that makes sense.
All right.
Cool. All right. Yeah, we're almost at time. How do you think you did?
Honestly, pretty terrible because I didn't think of like the object thing. I feel like there's no point in like trying to complicate what a task could be. Like, obviously, I should have like been able to like think about that in the fact where it's like if I make a new instantiation of a task with the same name or something, it's still a different object. I don't know why I couldn't think of that.
Yeah.
So I think if I just kept it simple and just did literally like kept it as a string or something like that, I could have easily just kind of finished this way quicker, and then I would have had time to actually like implement this part or any other parts
Yeah.
that would have been there. Yeah,
All right.
yeah,
Okay. Yeah. I mean, the first thing, the first piece of feedback is, I know this is a fake interview, but definitely have the phone off, or not off, but silent. Because
oh
if the phone
yeah,
goes
yeah,
crazy during the interview, like the chat was laughing about it. I was like, I'm docking him for that phone going off. But basically, if your phone starts going off in an interview, I would just
yeah,
silence it. Oh, give me a sec, silence it. If it
yeah,
starts,
yeah,
like if a candidate is just letting it go, the distraction, or it just gets distracting. But that's just one
yeah,
little thing.
for sure.
Just keep it silent. But I think overall, when the you started off good, clarifying well,
Yeah,
and then asking like having good clarifications, like what is the task actually doing, what is a dependency. You're asking how many dependencies there are. I think it was good that you started building out classes, but yeah, that you just had that issue with, just make sure you understand the difference between comparing by reference and comparing by value. So that's why when
yeah,
you're checking if task is in task.dependency, since the key was a reference to the object, and those are two different objects, it will like never get anything in there.
right.
So yeah, you should be able to debug those pretty fast. You'll see a lot of errors like that, so just make sure you understand that.
Yeah.
Um, you wrote the test cases really good. I mean,
Okay.
you added way too many data structures. You have three maps and one array here. This could be solved with way less data structures.
Yeah.
So yeah, the code is a bit messy when it comes to that. And
Yeah.
yeah, just the way that you structured the code, you could have done it in a lot cleaner way, with less issues. Because I
Right.
think,
Right.
yeah, having a list of current tasks and then having a map from dependency to task could be a lot more simplified. Like current task and name to task. Like you could probably just have name to task
Right.
instead
Right.
of
Yeah.
current task, and then when you need to print out the task, just loop through the keys. So yeah, I'll just work on like having simple making the code a lot simpler.
Yeah.
Other than that, I mean, you pumped up like you have a good structure to it. It's just getting to the right answer in the solution. And second part, yeah, topological sort makes sense. I think I just asked you to determine if it's possible. So even topological sort might be overkill. You could just do a cycle detection. But
Yeah.
part three was gonna be, um, can you actually print the task in the right order? So yeah, topological sort would have worked there. But that's something I would ask.
Mm,
Like, oh,
okay.
or it just kind of shows that you're thinking ahead. If you're like, okay, there's
Yeah.
a simpler solution, which is a cycle detection. But you could do cycle detection with topological sort too, or just a DFS. But
Yeah. I think
yeah,
honestly, yeah, I know you could just do like an easy DFS cycle detection, but for me, it's like this is more intuitive
yeah,
the way that I think about it. So I
yeah.
wanted to do it this way,
There's
but
multiple
yeah,
options that you could mention. But
yeah.
yeah,
Okay,
I
I see what you're
wouldn't
saying
dock you
though.
on that. But yeah, I think just the reference part and just try this question and try to simplify it a lot. I feel like you can get this same objective down with less data structures without having three maps and one array. You could probably get it down to like one maybe even just like one set or one map.
Yeah, yeah. I mean, I definitely could have just deleted it. Yeah. Okay. All right.
Cool. All right. Thanks for hopping on.
Yep. Appreciate it. Thank you.
See ya.
Bye bye.
See ya. Yo, everyone. I'm gonna have my friend who's a UPenn graduate turned AI engineer hopping on the chat. Wait, let me fix something. Must Yeah, like it could be simplified a lot. Basically, that's my main feedback. One sec. Yeah, we're doing after my friend hops on. We discussed AI engineering. Do this. Get this guy on. Yeah, we're gonna talk all about this stuff. So wait, I message him. Yeah, yeah. Trust me, everyone's gonna get their questions in. Also, I'm talking to one of the people who runs like talent at Kleiner Perkins. Kleiner Perkins is one of the biggest VC funds in Silicon Valley, and I'm gonna try to get founders and CEOs and stuff on the stream so we could just grill them or ask them questions. Nabil, hold up. Yo, Nabil, what's up, bro? Hold up, let me get my camera working. Give me a sec. Do you hear me?
Hello?
Yo, yo, yo. Do you hear me?
Yeah, yeah, I can hear you. What's
Let
up?
me reduce my. Hold up, let me fix up my. Put you on the stream. Yo, long time, long time.
It's been what, 3 days?
3 days. Are you still in SF?
I'm back in New York now.
Hold up, let me fix my.
Back in New York.
Wait, let me join up with my other. If you want to see me, do you care to see me? Probably weird talking
Uh,
to the. Doesn't matter.
y- no, it's okay. If you can't get it set up, that's fine. No problem.
No, cause I. Are you looking at the stream? Like I got you popped up on the stream too.
No, I'm not actually. I'm just looking
That's.
at Castle Ridge Labs.
Wait, let's see. Okay, wait. Let me set this up. Then we can hop into it. Join here too. Oh shit. Give me a sec. Tweaked. Give me a sec. How do I turn this off?
Good.
Wait, can
You're
you see me?
usually in the streams, right? You're usually in the videos.
Yeah. You can see me, right? I'll just pop it right here.
I could see you.
Alright, hell yeah. Am I usually on the stream? Yeah, yeah. Okay. Let's bring on my questions. How's it going for you? Is it late for you?
Good, it's good. I mean, I just got back from Tulsa, Oklahoma.
That's so
For
random.
Yeah,
What's
I
happening there? Like
stopped
a
there on the
wedding?
way back from SF. Yeah, yeah, I went for a wedding and I
Nice.
got back a few hours ago.
Nice. Cool.
Um,
Man, thanks for hopping
yeah,
in.
yeah, man, for
Let's
sure.
talk about. Let me bring out the notes. Let's see. Wait, let me bring it up. You're a sweet turned AI engineer. All right, let's start this up. Start up this interview.
All right, man. How does this
So,
work?
so literally, I don't know. This is kind of a new format, but what I've been trying to do is just. I mean, I've been just doing all this coding stuff, but what I'm gonna do as soon is just get people who are like, I don't know, doing cool stuff like AI engineers, founders. Gonna hit up some CEOs and try to do like podcast style, talk to them about like just ask them questions that I don't know, chat wants to hear or
Yeah.
chat wants me to ask. Or
Oh,
yeah, just like
is it a
different
live stream?
like yeah, you're literally on live stream.
Hell yeah.
Yeah. I don't know if let's see how much people. Yeah, we got 30 people watching, so we'll just get straight into it. I think before I start the video cuz we're doing this live and then I'll also chop it up into a video. But the
Okay.
chat might have questions to ask you, but probably just we'll do some quick introductions or just introduce yourself and then we'll just talk about all those questions that I already forwarded to you.
Yeah, for sure.
Yeah. Oh shit. I accidentally cut you out. It's like, cool. All right. I'll start up the video. Hey everyone. So today I have my friend Nabil, who is a AI engineer at Airtable, and yeah, University of Pennsylvania grad. Also, while he was in school, he was working at a startup. Like he co-founded a startup that they eventually sold to Lyft, which was pretty cool. So yeah, I worked with him out here in Silicon Valley. He moved out to New York, or I think he's always lived in New York, but has deep ties in Silicon Valley. So yeah, just had a bunch of questions of just some of his early life, getting into UPenn. A little people are curious about the acquisition. Um, what else? Yeah, just like how did you transition from a suite to AI engineer, all that. But yeah, want to just start off telling us a bit about your background, maybe where you grew up and some of your early interests?
Yeah, for sure. Thanks for having me on. Um, yeah, so my background where I grew up. So I've always been on the East Coast, sort of like you mentioned.
Yeah.
I grew up in the Philly area, so the Philly suburbs. My family sort of settled there. They came over from Pakistan and like they settled there. So I was born in that area. I grew up there. I went to like high school, like all grade school there. Um, and I mean, I was just pretty normal. Like I was like, really into sports. Honestly, like I was really into just academically, I was always very into math,
Mm.
right? So I always loved my math classes a ton, and I knew I wanted to do something related to math. Um, Originally, I had been sort of interested in uh, doing mechanical engineering or civil engineering because I was like just fascinated by, you know, building things. I've always been very into building things. Like I did a lot of science Olympiad stuff, where you had to build like, I don't know, towers or vehicles or things like that. Um, so I was like sort of fascinated with building things, and I actually like started off college, mechanical engineering. I
Oh,
didn't
really?
do any CS. I had very little exposure to computer science or anything like that. I was kind of trying not to do computer science. I was like, this is too basic. Let me do something more interesting.
Yeah.
So I was like, yeah, I was also very into electric cars and just like, you know, um, environmental things and like energy and things like that. So I had started off mechanical engineering actually.
Wow.
So like this is a good way for me to use my math stuff and like apply it into like something that actually interests me. And I was also just always interested in business. Um, I was always interested in like, potentially starting a company and things like that. We can get more into that later, but
Yeah.
that's a little bit about like what I was interested in growing up, and how it sort of translated into what I ended up applying to college as.
Yeah. So how did you even get interested in math? Were you just taking math courses as and you're like everyone's saying you're good at it? You're like, okay, I actually like this because I'm kind of good at it. Or were you doing like Your parents were putting you in competitions or making you to do math
Um,
tutors, Kumon or whatever?
no, I never did Kumon. Um, I always just I liked the problem solving aspect of it. I think, we had math Olympiad competitions in school, and I always just like loved those and would try really. I was such a try hard. I would try so hard for all of those, and like
Yeah.
it felt fun to me. It felt like a puzzle. I was like interested in like puzzles and math and like problem solving. And I think maybe part of it is like growing up. So I had a long commute to school. So
Mm.
I would have to go like half an hour, or 45 minutes basically one way every time like to go to school. My dad or mom or whatever carpooler would take me, and like we had these books, like it was either like Sudoku or like like brain teaser puzzles or whatever, and like I would just like put my head in those like
It's
the entire
crazy.
ride and just like solve those, and that was so fun for me.
Yeah.
I was a little bit of a nerd, I guess. I don't know, but um that's sort of what I like. It got me into it. Also, like my parents and like my whole family, even my like grandparents were very much like, like you like math, like let's like, like make you really good at math. So they would like in my summer vacations would make me like, like do these math books, mental math, like just like be really fast
It's
at
crazy.
multiplication and stuff like that from like a young age.
Yeah.
So I do owe a lot of it to my parents, like, nudging me a little, but I
Yeah.
always had that like inclination of like I love puzzles and solving problems.
Yeah. No, that makes a lot of sense. Like, I don't know if my kid was doing math and liked math, I'd be so happy because a lot of kids don't like math.
No, no, mind you, I wasn't like a perfect kid either. Like I also loved wasting time and
Yeah.
playing video games and doing stuff that's not productive too, but I happen to like math.
Did your parents sort of make you or enforce playing games if you played games too long, get off it and go do some math, or they just let you
You
slide?
know, sometimes, I mean, they weren't, they did limit my like video game time, and they limited like the amount of time I'd watch TV. I'm pretty sure I wasn't allowed to watch SpongeBob for a very long time.
So random.
Um, Yeah, yeah. I mean, apparently it was a bad influence.
Yeah.
But this was when I was very young. But then I kind of it did like instill a habit in me that like, like these are my priorities. Like my priority is not to like be really good at Call of Duty. My priority is to like, be cracked at math or
Yeah.
something,
Your
like
parents are great parents. I'm gonna literally do that with my kids.
no, I mean, yeah, I do owe a lot of it to them.
So how was it getting into University of Pennsylvania? Did you sort of have your sights on University of Pennsylvania, or were you looking into other schools as well?
Yeah, so actually it was pretty much the only school I applied to. I applied early and I knew I wanted to do something business related.
Mm.
I didn't want to just purely be an engineer. Um, so I thought maybe I would do like a dual major or like econ or like engineering and like minor in business or something like that. So I was thinking about like what are some like good business schools, good engineering schools. So and also like Penn was close to home. It was pretty familiar to me. I liked Philly as a city. I could like, sort of stay near-ish to my family and
Yeah.
also like have my own life in Philly. And then there was also this like entrepreneurship scene that was starting up there, um, and getting like stronger and stronger every year. So I applied early to Penn. Um, like I said, in mechanical engineering. But it was always a school that I thought was a good fit for what I wanted. Obviously, there are others like Stanford, like MIT, things like that. But um, Penn had always been like, close to home, like familiar, and like also really good. Like I liked Wharton a lot. I liked the engineering school a lot. I took some classes there,
Hmm.
or I just sat in on some lectures there, and I was like, this is really cool. I love the robotics program that they have here. And yeah, I applied early and luckily I got in.
Oh, that's crazy. Like did you study a lot for SATs, as in you were doing practice tests, paying for like, SAT tutors and stuff?
I did do that. I did study a decent amount for my SAT. I actually took the ACT and sent in my ACT. But yeah, I did a decent amount of practice for that. I had a tutor. Um, yeah.
That's wild. What was the culture like there in University of Pennsylvania once you got in? Was everybody insanely driven, insanely like cracked at math as well, or I mean, was there a spectrum?
Yeah, it's interesting. Penn is so everybody's quite smart and everybody's driven. I would say driven is probably the biggest thing. Everybody at Penn was extremely ambitious, and they're ambitious. Like there are different flavors of this in different schools. Like
Mm-hmm.
some schools are like, oh, like I really want to discover something, or some schools are like, I really want to like publish a lot of papers, or like or like I really care about philosophy. Like there are schools that are different, sort of like flavors of ambition.
Yeah.
And Penn's ambition was always very much like practical. It was very much like I need to get like a crazy finance job right out of college, or like I need to like start a company and like have scale it like to some crazy amount and like put it out there in the real world. It's very practical, applied, pre-professional in some ways. So that's like you kind of notice that immediately when you get there. And also, like, you definitely feel the impacts of Wharton, even if you're not in Wharton, if you're in the
Mm.
college, if you're in the engineering school, even if you're in the nursing school, you sort of feel the impacts of like, okay, it's important to learn stuff about business. It's important to not just think about your own discipline and like um, think about how you can apply it to the real world. So that was pretty palpable.
Oh, yeah, that's interesting. I like how you mentioned that. Yeah, different schools have different like drive. Like some schools, for example, Waterloo, not taking any shots. I feel like it's more like, how many internships could I get? Could I get a quant? Like people are super driven for landing those big internships and landing a ton of internships and getting into Fang.
Yeah.
And maybe Ivy League is different in University of Pennsylvania, because I actually did notice that a lot when I got into the industry. I noticed a lot of Like a lot of the people in the schools that I would go to in Canada, their main drive was to get a really good job or be able to crack big tech or FANG. Whereas
Hmm.
a lot of the people who graduated from Ivy League schools like University of Pennsylvania, like yourself, like you, a lot of you guys like decided to join early stage startups or very small startups or start your own startup after college instead of trying to get like a big tech role. That's like one big observation I made. So maybe it's just like what you mentioned there is people are driven. It's not just to get a good job and make a lot of money. It's driven to like build a successful company.
Yeah, yeah. I mean, I definitely do think there are a good amount of people that go for like the FANG jobs, the big tech jobs at Penn too, and the Ivies. But I think there are definitely high percentage of people that want to do like that don't want to just purely be an engineer necessarily, right? Like they want to be an engineer
Mm-hmm.
and a founder, or like an engineer and an investor, or they want to do engineering at a financial firm like in quant or something like that,
Mm-hmm.
right? Um, so yeah, I would say like that is one of the biggest differences.
Yeah. No, that's really interesting. That's a good take. Um, so, how was it to start a company during your school? What was that like, and how did that company come about?
Yeah, uh it was a lot of work and a lot of fun, I would say. Um, so I sort of like I mentioned, I always wanted to start a company, and part of it was because it was like this really hard thing to do. It's like
Hmm.
it was like people would say like only 2% of companies actually succeed, and I was like, shoot, like let me try to be the 2%,
Yeah.
you know? And it was this hard challenge that like I really wanted to do. Um, and there were other people at Penn, so because Penn is like such an ambitious place, like other people at Penn like were like, yeah, like I want to do that too. Like I want to
Hmm.
do a hard thing. Like I want to shoot my shot. I want to start a company. So I met a lot of actually a lot of my friends happened to like be part of this like a mindset too, that they wanted to build stuff and put it out into the world. Um and uh yeah, I mean, like we'd talk about ideas. We'd have a bunch of different ideas that we would think about, and we eventually settled on this idea, Halo. This was in my sophomore year. I remember walking with the CEO of Halo, Kinan. We were walking down from a class. We were walking through Philly, and we were just talking about how digital advertisements are very targeted and they're very, sophisticated, and there's a lot of tech behind them. But we looked around at the billboards in Philadelphia, and like they were so low tech, nobody was really looking at them,
Hmm.
but they were still paying for the ad space. People were still paying for the ad space. Um, so uh we were like, okay, like how do we bridge this gap, like what is like the solution here, and we sort of came up with this idea that like we can modernize these ads by putting LED screens on top of Uber and Lyft vehicles, and like as they drive around we would target the ads based on the location or the time of day, like the demographic of people that live there, and apply this like targeting technology to the outdoor world. So that's sort of how the idea of Halo came about. And then we just got down, like we just started building.
That's crazy. And is this you
Yeah.
two at first, or how many people?
It was us two, and we had somebody else. We had two other people. So it was four people that started the company. So I was basically CTO of the company, in charge of the tech and product. And then we had a CEO that I mentioned, and
Hmm.
someone else was in charge of marketing, and another one was in charge of sales.
So you pretty much just sat in a room and came up with ideas, and then it's like, okay, this is sounds like a really good idea. Let's go for it.
I mean, this was like just what we would talk about at lunch,
Yeah.
like we would just like when we were hanging out, we would just be talking about this. Um, and then we just sort of like the Halo thing sort of came about on a walk.
Yeah.
It was just like in our free time, all our free time, we would just spend talking about startups.
So how did it go from sort of just an idea to beginning to execution and actually building out a product?
Yeah, so we started pretty quickly actually. So this involved some hardware. we realized that there were some pretty like off the shelf hardware units, like LED units that we can buy from China, and sort of like retrofit a little bit to our needs,
Hmm.
um, and get going. So we started on the product pretty much immediately because like we went to Alibaba and we were like, okay, like let's see what we can import from China. We started talking to these Chinese manufacturers on WeChat,
Crazy.
um, and then we got a unit shipped. Then we went to a mechanic nearby, like learned how to like hook it up to a car, and then we hooked it up to actually to my car. My car was the first Halo car. It was like the first pilot car. And
Damn.
we just got it running. We built like an iPhone app. We started getting like drivers to sign up. And it was crazy. Like as soon as we got the idea, every single Uber car that we got into, we would pitch the idea to the Uber driver. Then we would get their contact and then we would put them on the wait list. And we had
Nice.
this huge wait list of drivers that wanted this on their cars, and they really liked it because it could like help them get a more, like it could help them with their wages, like they get passive income from this.
Hmm.
um I know the time when there was a lot of protest about like people like Uber drivers not having enough wages, so that was really cool, timing and really cool problem to be working on. And it was cool to see their excitement as well. um but yeah, I mean, we just like put our heads down right away, like started building as lean as possible, off the shelf, like as minimalist as possible, like MVP. We put it out there. We ran some initial pilot tests. We got some like very promising data. And yeah, that's how we started.
That's crazy. So, like, even figuring out the hardware part, because for anyone in the chat who's wondering what it is, it's literally a LED screen on top of the Uber roof, right? Or any car you mount it on top of the roof, and you target ads based on location, and you're showing like what kind of quality were the ads? Was it just dynamic or was it like a video?
Yeah, so they were dynamic ads. Well, some of them they were just static, but mostly they were like dynamic ads. They had some sort of like video, like attention grabbing component to it.
Animations, no, animations and
Yeah,
stuff.
some little animation here and there. But that was the whole idea. Was like we wanted to be more engaging than other ads.
Hmm. So you looked on WeChat, the manufacturer built out the whole thing for you, the whole LED screen that you would mount, or you just had the parts and you assembled it.
Well, they pretty much built out the whole housing unit
Wow.
of like with the LED screen, like the like metal and everything, um, like the frame and all that. So they built that all out.
Hmm.
Um, what we did was we kind of like picked which microcontroller we wanted.
Hmm.
Um, and then we had to, you know, so we picked the microcontroller, and then we mounted it on the car. We did like the whole like we had a whole process to connect it to the car battery. We had a whole flow for that, that we figured out. And then we also had an iPhone app that like communicated to that microcontroller that we put in.
Hmm.
Um, the targeting technology, like all of the like logic would happen on the iPhone app that we built.
Hmm.
And this would be like the driver companion app.
Hmm.
Um, and that would essentially like tell the LED screen what to play.
Okay, and it's hooked into the location and everything. Like the app is hooked into the
Yeah, yeah.
location of where the driver is, and it sends that over. Was it like
Yep,
Bluetooth or
yep.
Wi-Fi or
It was actually
USB?
it was a local Wi-Fi
Okay,
connection, yeah.
nice.
So the microcontroller made a little Wi-Fi connection that the phone would connect to. The
Dude,
phone would be connected to cellular data, which would have location data, and then we would just pipe in the information through there.
no, that's crazy. I mean, you probably learned so much from just trying to build out that project, like that company.
Definitely. The learning was insane. It was learned everything from very low level, like okay, like how to like talk to a microcontroller,
Yeah,
all the way to like the highest level of building a company, like how to sell to customers, how to raise money, how to hire people, like all of these things and everything in between. It was a great, phenomenal way to learn about how to build a company.
yeah. I mean, because people all the time are always in the chat, like, what side project should I do? What project? Now I'm always like, come up with something cool. Find problems in this world that you want to solve. Because if it's a problem that you want to get solved, you'll be motivated to work on it and build out something Like build out a project to solve that problem. Don't just build random to-do lists and weird React apps and put it on your resume. Like those, I feel like those aren't as great as. I mean, you probably had so many opportunities that opened because you built this company while you were still in school.
Yeah, I mean, I definitely think it opened so many doors. Um, and not only that, like to your point, like you're so right. Like what I always think about is that it was so much easier to get started on this than I actually expected initially. Like it's so much easier to build a company. Like, okay, like you might have to incorporate with like Stripe Atlas, but then you have a company, right?
Mm.
Um, and then building an MVP, it's not that hard to build an iPhone app. It's not that hard to like, you know, ship one unit from China, and then, like play around with it. Um, and once you like really get into it, it doesn't feel like it's a lot of work all the time. Like we were working crazy hours, right?
Mm.
We were like going to school, we had to leave lecture in order to like so for example, like a driver in Philadelphia might have had like some sort of issue with their monitor and they'd be like, "Can you send over a technician?"
Yeah.
But we didn't have technicians. Like we were the technicians, right? So we'd have to leave class and like, put out fires in the middle of the city here and there. But if you enjoy what you're doing enough, like just the fact that you have ownership over this whole thing, like the fact that this is your product and your company, it really it's motivating and it makes it feel like it's not that like it's not always like work. It feels like fun at some point, right?
Yeah.
So don't get me wrong, like it does also feel like work. It is like not easy all the time, and like there are lots of ups and downs that you have to be able to push through. But um, it's I guess it's different from like a 9 to 5, because you feel so much more agency and ownership.
Yeah. That makes sense. What? How was sort of scaling it? Well, I guess how did you get your first customer, and then how did you scale it up to however many customers? Like, what was the peak before you sold it to Lyft?
Yeah, good question. So the first thing that we did, we had one driver.
Mm-hmm.
We had one pilot driver that, we trusted that drove a lot around the city in Philadelphia, and we put the like we put the monitor on his car, and we just ran AdWords campaigns. So like nobody knew. So our website was halocars.co. Nobody was going to that website because nobody knew what that was, right? Like
Mm.
we had no brand awareness. Like we were just like a few kids like with this website. So what we decided to do was we decided to put this ad on top of this one driver's car that said Halo Cars, right? Like nothing but like halocars.co. That's it, right? And we made a little animation to make it exciting and engaging. And then we mapped where the driver drove around. And then we put out a Google AdWords campaign that showed people searching for Halo Cars and people clicking on the website,
Mm.
right? So, and then what we found was that it mapped very cleanly to where the driver drove. So there was like actual real data that showed that the driver drove in these regions, people were searching for Halo cars in these regions. So we are like, okay, like this advertising kind of works.
Yeah.
um so then we were able to take that to some of our like initial pilot customers. They were just like businesses in the city, businesses in Philadelphia. And they would run like subsidized, like we would do like very subsidized ad campaigns for them. um Also with the same like intention of like we're just using this to get good data and like show people that we have value. um so we did that for a bit. So those were our first, like those were technically our first paying customers were some advertisers in Philadelphia. And then we actually decided to move to a bigger market. So we moved to New York. We raised a pre-seed round and we bought a bunch of monitors. Actually, one of our co-founders went to China to like see the whole manufacturing process
It's
and
crazy.
see, where can we save money and like where can we customize and things like that. And then we bought a bunch of monitors. We had a few more paying customers in New York, and we were really getting ready to scale it up big time. We were getting ready to do a seed round and get more customers and get more drivers on. But then the Lyft acquisition happened, and we decided to sell.
That's actually an insane story. So the first, so it's kind of like a marketplace, right? You need to put a bunch of LEDs on cars, but then you need to get advertisers actually on there or like make the
Yeah,
connection. So you just went
yeah.
door to door, maybe offering it for free. Like, I'll put your company on this ad for free just to gather data. That's kind of what you said.
Yeah, initially we were doing free or very subsidized campaigns, yes. So yeah, you're right. It's a two-sided marketplace. We had one side with the drivers, and the value add for them was very clear. Like they would get passive income if they just put this on their car.
Mm,
So we had a long wait list of drivers, and we just pretty much chose the best drivers, like the drivers that would drive the most in like the high traffic regions. And then we had to work on the other side, which we had to like first do some free campaigns, then we had some good data to show, and then we did some paid campaigns, and we built it up like that.
I see. What sort of metrics were you tracking? Was it like cost for conversions?
Yeah, this is a good question. We had a bunch of different metrics. It's a little hard to do conversion measurement. Um, Initially, like we didn't have like a great way to do this. Um, we would do things like, okay, like if you're advertising with us, you put a promo code, like promo code Halo or something, and we'd see how many people use the promo code. And then we'd have like proxy metrics like, like this is the amount of foot traffic, excuse me, like this is the amount of foot traffic in this region. And like based off of like how much the driver drove in this region, we would estimate how many people saw it, right? So it was hard to like do like actual like CPM metrics
Mm,
initially, and that actually came a little bit later on. Like it became more sophisticated at Lyft. Um, but yeah, initially we had some like rough metrics where we would go to advertisers with.
nice. So another question related to just raising money. How was that process of raising pre-seed? And yeah, let's talk about acquisition after.
Yeah, I mean, raising money, we didn't do a ton of raising. Also, we felt like raising was a necessary evil. Like it was a capital intensive thing. Like we had to pay upfront costs to buy these monitors, so we
Mm,
sort of had to raise. Um, but the margins on the business, like the margins on like, advertising dollar spend to like paying the driver, like we thought we would have pretty healthy margins. Um, but we went around to like some angel investors, some like we did some competitions at school. So initially we did some competitions at school that got us some like free grant money
mm,
to get a few monitors and stuff like that. But then we went to like some student VCs, we went to some like institutional VCs and pitched to them. We actually like applied to Y Combinator and we got an interview, but we didn't get Y Combinator. Um, and then we raised from some angels, and yeah, it was an interesting process. We got told no a bunch, um, and but we were able to raise, and like we went through the whole process of like due diligence. Some of our investors actually came and like sat in a car with us and like wanted to see like the ad change based on location, like
it's
wanted to
crazy.
like test out the product a little bit, and that was cool. So it was cool like doing all of that and signing our first term sheet and going through that whole process. And then we were getting ready for a second round, and we weren't actually like planning on selling the company or anything. We were kind of planning on making this a standalone business, but then um, Lyft reached out and the acquisition happened.
They just reached out randomly to one of you, like y'all.
Yeah, so I think they always they sort of had an eye on this because we had some press, like there was some like articles written about us and
Yeah.
things like that, and the drivers were talking about it. So they had an eye on this, and they had initially asked for a partnership. So we took a meeting uh, to talk about a partnership, and we took a few more meetings to like discuss the details of the partnership. And then after a few meetings, they were like, "Okay, you know what? Like, we don't want to partner. We want to actually acquire the company." And we were like, "Oh shoot! Like, you know,
That's
what are we
crazy.
gonna do? Like, we need to make a decision about this." Um, and then we ended up like deciding to go through with the acquisition.
That's wild. And everyone kind of had to sign off, or did some people have more say than others?
Um, I think like the CEO really had the most say in this. Um, but we were all pretty much in agreement about
Yeah.
this.
So
Yeah.
when it came to actually pitching and building up the user base and getting funding, did you already have the product built out and already had the first people using it, or did you
Yeah, we
sell
had a
it?
product built out.
Nice.
Yeah, we had a product built out. We had the iPhone app, we had the driver dashboard. The driver dashboards, so sorry, the advertiser dashboards, that was sort of being built out still and was still in progress. But we had the core product of just um, the iPhone app that talks to the monitor that we had built out very early. And it was very lean. Like we tried to make it as lean as possible, MVP as quickly as possible. And um then we were able to sell, to a bunch of people. And and then like, people wanted more sophisticated tools of like, oh, we want to see where the drivers went, we want to see like how long they spent on using our ad. So we built out some dashboards and
Mm.
better products for advertisers afterwards.
Chat's asking, did you have a patent for it? Did you have to get a patent?
No, we did not have a patent. Um, we didn't have to get a patent. It might have been interesting to see what would have happened if we got a patent and we could see like what would have happened with the price. Like maybe Lyft would pay more for the IP, but patents do also take a long time to go through, and also it's like very easy to get around patents in tech. Um, so we felt like it wasn't that worth it to have a patent.
I see. I mean, okay, it sounds like everything went smoothly, but I know that's not how life goes, and not that's not how startup goes. Was there any times where like rough patches in that whole journey of building and selling that startup?
I mean, definitely there were times when, we didn't think it would work, especially in the beginning. Like we got told no so many times by investors. We applied to YC twice actually, and we got told no twice. We applied to YC literally a week after we started the company when we had nothing but an idea. And they were like, yeah, essentially like we think this is solid or whatever, but you need to figure out how you're going to scale.
Mm.
And like we don't think like we think it's going to be like difficult to scale this because it's like a chicken and the egg problem
Mm.
where you need a bunch of, capital to have a bunch of distribution. Um, but you also need distribution to have value and like sell to people. Um, so we tried not to be like discouraged by that. That was like literally week one, and we were like,
Yeah.
okay, whatever, we'll figure this out. And we applied to YC again, with a lot more traction, with a lot more just like excitement and like hope that we get it. And then we didn't get it. Um, I think like there were some concerns like, okay, there's competition in the space, and it's like an arms race of funding and things like that. And we like that did to some level affect like, okay, like, can we actually do this well? Like, can we actually like outraise our competitors? We can't even raise like a small round from YC. Um, but like the team definitely did have a lot of belief. And yeah, like I think like somebody on the team, like if you're starting a company, at least one person on the team needs to have like unwavering optimism and just like delusional optimism that the idea will somehow work. And if it's not that idea, we'll pivot to some other idea. But like this team and like this problem space will make it work somehow, because that energy is actually infectious and it carries throughout the team. Because if some people are down about like not being able to raise money or not being able to get like customers initially, that like infectious like drive and optimism and like vision really does impact like the motivation of the rest of the team.
No, that makes a lot of sense. Even working at a company, if like morale is low, it tanks everything. You need somebody to be there to hype you up and
Yeah.
work hard.
Yeah, and it needs to sort of like be genuine and like you need to sell the team on it. Like sometimes you can be like too delusional and like people get turned off, but like
Yeah.
if you have people in your team that are like really good at rallying, that makes such a huge difference.
No, that's really good advice for anybody out there trying to start a startup. Just make sure that, I mean, why do you think that person was so optimistic? Was it just they're just so passionate about the idea? Is it just their personality? Was it
Uh,
you?
it, and it was, I don't know if it was me necessarily. Like I tried to have some of that, but I think, there are some others on the team that really had like a lot of like drive and vision, and like relentlessness. And I think like maybe part of it was their personality. Part of it was like they read a lot of these like startup books and like would read a lot about like the early like internet entrepreneurs and like their approaches to things and stuff like that, and wanted to emulate that in our company.
Yeah.
Um, but but yeah, I mean, some people just do have that personality where they're like so persistent, they never give up on something that they believe in.
Nice. Yeah, that's crazy. I want to get into sort of what you're doing now too. That's really good insight into that. Like we could probably talk about that for days. Chat, if you have anything you want to ask, mention it. But yeah, what are you up to now? Like you sold your startup. That was when you were school. You were working as SWE for a bit, and now you're an AI engineer. What's life as an AI engineer right now?
Yeah, so SWE for a bit. So still technically like SWE, and I'll get into that. So um yeah, I mean we worked together at Nova Credit for a
Mm,
bit, and then worked at Airtable. So the last 3 years I've been at Airtable. Started off full stack engineer on working on the public API. So I was doing a lot of like OAuth, things like API security and stuff like that, developer facing tools. I also worked on like the Airtable and Workday integration, um, so things like that. And I was doing a lot of like full stack product work, but I was always very interested in AI. I had like concentrated in AI in undergrad, so I took some like higher level AI classes at Penn, and I wanted to apply that somehow in at Airtable in my like day job. I just this was even before ChatGPT
yeah.
and everything, right? Um, but there was no actual AI product at Airtable. And
Mm,
I was like fairly like, young. Airtable has a lot of senior engineers and like
yeah.
is very skewed towards senior people, which is probably, which is part of the reason why I wanted to join because I felt like I could learn a ton from them and learn a lot of best practices from industry, from people who've done it before a few times, right? So um, that's sort of the reason why I wanted to be a software engineer, even after being a founder. Um, but yeah, I mean, then I like worked on some AI, like an AI project in a hackathon. This was before ChatGPT came out.
Mm,
It was like soon after I joined, we had a company hackathon,
yeah.
and I was like very motivated to build AI stuff. So Airtable has like this concept of fields. The main product is like a spreadsheet product, and they have like fields or columns. So I was like, okay, like why not build like an AI based field. So instead of like using formulas, you can just type in natural language and like, get some sort of formulaic output or get some sort of like AI constructed output. This was using, I think, GPT-3. Um, and
Uh,
like me and a few others built this at a hackathon. And yeah, that was the first ever like AI introduction at Airtable. And then later on, it sort of became a product. So they like staffed this project with like senior engineer, like the senior engineer, and um, and then ended up like creating an AI pillar and an AI team. And I was able to join that team and sort of like work on this stuff, like work on like the agent product basically from the ground up. Um, so yeah, I've been doing that for the last like maybe couple years or so, and now Airtable is like a very AI first company. It is like if you go to the website, it's like basically AI native now.
I
So
see.
it's really cool seeing that from like going from nothing, no AI product at all, then going from like a hackathon project all the way to like AI being the entire company and like
Yeah.
going through that whole journey. Like that was very exciting.
Oh, like so many companies are getting into AI and shifting their focus into AI or building AI products.
Yeah,
It's
for
crazy.
sure. I mean, it's all everyone talks about,
So,
right?
so when you took the AI concentration, what was sort of the focus there? Was it more on like traditional AI models, like neural networks and traditional AI techniques?
Yeah, pretty much. I mean, there was like a pretty strong emphasis on like deep learning, I would say. But sort of like I said, I came into Penn studying mechanical engineering. I was really interested in building physical things. I was interested in robotics. And then from there, I kind of was like, okay, like I'm really interested in like this artificial intelligence stuff, right? Like I became more interested in CS rather than like the mechanical engineering, but in particular artificial intelligence. So like I started taking some classes. I took some classes in natural language processing, um, just like some of like math behind machine learning. It was all very classical, like went through all like the different types of machine learning models and like it was very math heavy. And like I said, I really like math, so I enjoyed those classes a lot. Um, and like um, there were some classes on like data labeling, there's some classes on computer vision. There's a lot of like, classical machine learning and like AI techniques.
Yeah. Oh, that's crazy. What? How do you think AI is gonna shape the industry?
Which industry are you talking about? This is
Anything?
a loaded
How's
question.
what industries do you think it'll affect the most?
It's funny. I mean, this is I can't predict the future, right? But like from my read on the market, I think um there are a lot of like back office tasks that are like that maybe don't need to be like 100% accurate that AI can automate and do pretty well. Um, and then there are also like, more like white collar type tasks that and it really depends on each industry's level of like willingness to adopt new technologies, right?
Hmm.
Um, so so there's software engineering and like technology. There's like medicine, there's like law, like there are all these different domains, right, that are like white collar domains like knowledge work. But I think like every single industry has a different willingness to accept new change. Um, and sort of as you'd expect, technology, like the tech industry, is really willing to accept new change because
Yeah.
they literally built it and
Hmm.
they have to compete with each other on innovation, right? Um, so like I do think like AI will affect software engineering a decent amount. Um, I do think it will affect law, maybe not so much medicine right away. I think like there might be like some social resistance, some like legislative resistance to like AI like replacing doctors or something like that,
Yeah.
Like it probably won't happen for a long time.
Yeah.
Even if the models are there, like it probably won't happen for a long time. Um, but in all of these industries, I don't foresee AI like completely replacing um human beings unless like we get to some like crazy AGI that like somebody discovers and like I said I can't tell the future like there might be like the path of like AGI where like it replaces like everything
Yeah.
like a lot of knowledge work and then there might be like a middle ground path where like it just makes people more efficient and like less people are in those markets. It requires less people to build the same amount of work. Um, and then there's like the path of like the AI skeptic, right? Like that like it actually won't help. Everything will be slop. Like every industry will be full of slop and um you know uh humans will never be replaced and like AI will never get there. I tend to believe in the middle path.
I
But
see.
who knows, right? Like who knows what'll be discovered when,
Yeah.
right? So
That's a good take. We have more questions coming in from the chat. Um, so, how important is classical machine learning knowledge for being a MLE, machine learning engineer?
if you're a machine learning engineer, so I think there are like different classifications of like AI engineer. It's
Mm-hmm.
sort of an overloaded term. There's like AI product engineering,
Mm-hmm.
which is essentially just being a full stack engineer, and you like use the current LLMs, you use like a lot of like models that already exist, and build it into product and like apply it into product. So that's like very akin to like it's a, sort of a subspecialty of just being a full stack engineer
Mm.
or product engineer, right? Um, so a lot of people fall in this category. And you don't really need to learn like classical machine learning techniques. You don't really need to learn the math behind machine learning in order to do this part well. I think it helps you with a little bit of intuition of like, what's going on behind the scenes with these models,
Mm.
but it's not really going to help you a lot. Like the things that help with that specialization is like, do you know how to use like eval tooling? Like, um, do you know how to like run good experiments, write good prompts? Do you know how to do fine tuning? Um, do you know how to like just like build good user experiences around AI? Do you know the ins and outs of the different models? Like that's gonna help you with like AI product engineering. If you're like a machine learning engineer, so there's like separate, like you can be a machine learning engineer or an AI researcher.
Yeah.
I think if you want to do any of those things, knowing the actual math behind the models helps, especially if you're a research engineer. If you're an AI researcher, yeah, you definitely need to know a lot of the math behind the models. But um, if you are a machine learning engineer, um, it could be applied. You could be like just doing applied stuff, but most likely you're not. You're like working on models themselves. In which case, yeah, it helps to like learn the math.
Yeah, 100%. If you don't know the math, how can you build out the model or create a new? Because maybe they're expecting you to even come up with a new model.
Yeah, though I would say there are some research engineering positions where you don't really need to know the math behind the models a lot. It's like you're sort of building algorithms and stuff on top of models that already exist. So you're doing like it's not like you need to know like machine learning per se, but like you need to be good at like algorithmic thinking. So like I would say it varies a lot by the position, and you can definitely get away with a lot of like AI roles without knowing the models. It's just like have some intuition. Like it's good to know how they work so you have some intuition around how to build them.
I see. So, which one are you? Which categorization are you?
I'm more of like a product engineer, AI
Nice.
product engineer. Yeah, we don't build our own models really at Airtable.
Mm.
We use existing foundational models.
So, what do you think is for people like who don't live and breathe AI? What are sort of the key concepts or tools that we should understand to be productive with AI?
So, do you mean as an engineer,
Yeah, I
like
guess
building an
for
AI?
for you exactly. Like, what are the key concepts? Pretend you wanted to train me up to become your
Yeah,
role. I'm just a regular SWE right now. What
sure.
documentation would you put me through? Like, oh, go look at Claude docs on fine tuning, or like, yeah, what would you push me to look at?
Yeah, I mean, I think sort of like I said, one of the things that would help is just learning how transformers work at a high level. Like you don't have to like read the entire paper and know it inside and
Mm-hmm.
out, right? But just know how they work at a high level. Know like, you know, the it gives you a good intuition of like what these models actually do, like how they like actually like predict tokens and things like that, right?
Mm-hmm.
Um, Also like there are different models out there. Like O3 is a very different model from GPT-5, which is very different from like, Sonnet 4.1. So just like the biggest, most popular models, I would say keep up with those. Like read up on, how they work, um, just at a high level, right? So all of these things will give you an intuition of like which model is good for what. Because when you're building like agents and when you're building things, like you need to sort of have a little bit of just like gut check or like intuition around like, oh, what should I use for planning versus what should I use for tool calling versus what should I use for this sub agent? What should I use for routing? So it's good to like just have knowledge on how these things work at a very high level. So that's the
Mm-hmm.
first thing I would say is like prerequisite knowledge. Um, and then it's like get familiar with all the tools. Like it's sort of the Wild West out there. Um, in terms of like AI tools, there's LangChain is a good place to start, like it'll like it's a good place start to learn how to like spin up an agent, how to connect it to tools. Um, it's good to understand what function calling is and tool calling. If you're building like an agentic product, um, it's really good to understand just how tool calling works. Um, and then I would say also get really familiar with evaluation. So at Airtable, we use Brain Trust for evals. Um, so a lot of engineering in AI ends up being experimentation. It's this is like one of the biggest differences from just, standard full stack engineering, is that you have to do so much experimentation on prompting, on like just building your agent router and like agent execution, like tool calling flow and things like that. Like you're gonna have to write really good tests and learn how to evaluate them. So like get familiar with tools like Brain Trust
Mm.
or Arise. And there are a bunch of different eval tools. Um, so I would say those are the places I would start with. Um, yeah, I can't. I think that's like a good place to start for sure.
Nice. No, that's a lot to get into. I think the problem that I always face is learning these tools. I'm just learning how to use these tools, but then I get FOMO of not knowing the math. I mean, you already know the math, so I'm wondering how much time should I spend trying to learn the math versus just straight up just trying to build something with the AI and just using the libraries that are given to me.
I would say only learn the math in detail if you want to do research.
Yeah.
If you know you want to do research. If you just want to build products, I don't, I mean, yeah, like maybe there's some FOMO about not knowing like the math, but uh, you don't really need to know the math. I think just like high level understanding is good enough.
Nice. Cool. I mean, I'm gonna send this to my. I'm actually gonna start digging into this then. That's actually good advice. Learn
Yeah, I mean, if you want, you could
transformers.
read papers, like there
Can
are a
you
lot
do
of good,
that?
like the Transformer paper that
Yeah.
Google wrote is excellent, like
Attention is all you
place to
need.
start.
Something.
Yeah,
Uh,
exactly. Like that's what launched this whole thing.
yeah.
And what's funny is that like some researchers who worked on that didn't even expect Transformers to be this good when trained like at such a large scale. They
Mm.
didn't expect it to be this good. So like it kind of shows that, this is sort of a black box even to the researchers. Um, that not everybody like fully understands what's going on with the weights,
Mm.
you know?
Yeah. No, that's really good insight, especially how you talked about how software engineers very like way less experimentation. You know exactly what you need to build, and you could write unit tests to just make sure the functionality works. I think
Hmm.
I tried to do machine learning before. I did like an internship in it, and that was the part that I didn't like about it. It's a lot of experimenting, and then I mean, if you don't have a good eval, you don't know if you're going the right direction. So you have to like cook up an eval, and it's a lot of like tuning. And, okay, how can I
Yeah.
change the input so that I can get a better accuracy? Like how can I
Yeah, it is
massage
it is
it?
a lot
Yeah.
of tuning. It's a lot of like prompt engineering and not just that, like it's a lot of context engineering actually. Like half of building a good AI agent is giving it the right context at the right time and giving it the right like tools at the right time. And that's something that you just have to like build and experiment with over time. And it's just like you have to be a little clever about it. And prompt engineering, I think, is like reductionist. It's
Mm.
not just prompt engineering. It's like you have to get context from all parts of your product and like do a lot of just general SWE work to like get the context in at the right time. You might even have to do RAG or like build embeddings, right? Like one thing we did at Airtable that I worked on a lot was embeddings.
Mm-hmm.
You put the entire base into a vector database, like maybe TurboPuffer, Pinecone, Milvus. There are a bunch of them out there.
Mm-hmm.
Um, and then you can like actually get the right information into the prompt at the right time. That's pretty much the whole game when it comes to being an AI product engineer and using existing LLMs to build compelling, high quality AI products.
Nice. Awesome. I mean, this Google Meets is about to kick us out in 3 minutes, but no, that was a good conversation. We covered a lot of ground. I still have like so much things to ask you. Eventually, we'll probably do this again.
For sure, I'm
But
down anytime.
awesome, man. Thanks, Nabil. Really appreciate it. Chat. They had a bunch of questions. I didn't know if I had time to ask all of them, but yeah, we're gonna hop back on these coding interviews. Thanks for being so willing to hop
Awesome.
on and talk about that. And
Yeah, of course, man.
you dumped a lot of
Yeah,
info.
love your channel, dude. But thanks for having me.
Yeah, thanks, Nabil. Appreciate you. I'll hit you up.
Yeah.
All right, peace.
Take care, man. Bye.
That guy's a legend. Holy. Yo, what chat? What y'all think about Nabil? W's in the chat. No, that guy is so chill. Let's see. So. Let me remove this. Yeah, yo, chat. What y'all think about Nabil? That was good. Yeah, that's dropping as a whole separate video. I'm gonna get a lot of cool people like that on this because once you're in Silicon Valley, there's so many people doing cool stuff, bro. Let's see. He's asking me is there a link to a stream? Yeah, I'm gonna get him the link. So I'm gonna get a ton of people. Gonna... Wait, I'm just messaging him real quick. Have you met Zuck yet? No, I haven't met Zuck yet, but maybe we'll get him on the stream one day. I'm gonna hit up some of the CEOs I worked for before, and just ask them to hop on the stream too. Like I'm gonna be talking to a bunch of CEOs. Yeah. And my setup is just so ratchet, but the thing is I know these people, so it's easy for them to just hop on a Google Meets, even though I don't even have like a Lex Friedman type setup. But I think it's easier this way where we just hop on Google Meets, because then I'll just be able to get people there a lot easier. Saying thanks to my bro. Yeah, I'd rather do this and just have people in the chat straight up ask questions. So I'm gonna get a bunch. I'm gonna post this video separately on its own thing, then just send it as a concept. Maybe I'll drop it tomorrow. All right, what do we have going on here? We got somebody coming on soon. We might have to take a little break because that was long. Let's see. Because we got 2 more candidates coming on the live. Yeah, we're going to get a bunch of people. Yeah, I haven't met Zuck. I'm actually there's so much people asking this question all the time, how to become an AI engineer. And even for me, I'm gonna take his advice here and try to learn some of this stuff. Learn a little bit about transformers, the paper, get familiar with LangChain, maybe just read the documentation and play around with the different tools. Evals are so important. So now we know a little bit about brain trust and how to use it. Am I interested in like LLM wrapper? To be honest, yeah. How do you handle such a large work capacity? I don't struggle with discipline, but after 4 hours of deep work, I'm fried. I don't know. I think first off, it's just a habit. So when I first started, I had low, like if I was doing work for 1 to 3 or 4 hours, I'd be fried. Even I would be reading a book, and while I'm reading the book, halfway down the page, I'm already thinking about something else, daydreaming. But over time, you just get more used to it, and things become second nature. Oh, it's too funny. Like things should become things will require less deep work as you begin to master it. So for example, when I first started coding, you had to use a lot of your brain in order to actually code because you're so new to it. There's so many bugs and you don't know how things work. It just takes way more mental capacity. But over time, it should become second nature to you pretty much, and you're not really thinking about coding. You're just thinking about what problem am I trying to solve, and just converting those ideas into something that works. And your fingers are just going, and the code is just going. There might be some things you debug, but it takes a lot less mental capacity. So I noticed over the years the amount of mental capacity it takes for me to get work done has decreased. So that helps a lot with working long hours too. Is that it's not that taxing. You could even do other things, like think about other things in your life while you're coding. But yeah, I don't know. I think you just need to get into the habit, slowly push yourself to work harder and work harder and work faster and work faster. But I think naturally I was just able to that was my main advantage that I noticed right away, that I could probably work on something a bit longer than the average person. So when it comes to, you have to use your strength. So if you find that you're smarter than people, which I don't think I was, then I mean, I don't know how you could use that because that wasn't really my advantage. But I think I knew right away that I'll be able to sit down and work on something longer than the average person. So I used that to my advantage and just grinded. And just grinding actually takes you quite a long way. I don't know if that answers your question. James, do you ride the bus to school, the shuttles? Yeah, I ride the bus to school. What are evals? Evals is how you evaluate the machine learning model. Eval stands for evaluations. So how I would what hours you've been working? Probably when I have to probably around 8 to 6, 8 to 5 usually. And then I work out. My sort of my schedule is 8 to 6 work, or whenever I wake up. Usually I wake up at 7, but you have to take time to get ready. And then I'll pretty much start working as soon as I am able to. So probably around 8. Then I'll work till around 5:30 to 6. After that, usually I'll go to the gym. And then the last 2 to 3 hours a day from 8 to 11, I'll make YouTube videos or make scripts or catch up on more work if I need to, kind of thing. So I kind of work 24/7. I wonder if there is individual variability in work capacity mentally. Every couple of weeks pushing beyond my current capacity results in vegetation brain. Yeah, let me think about this. There is probably variability in people's work capacity, but it's just hard for me to talk about because I feel like I just had a high, like I had a high work capacity and I don't burn out really easily. But I do have friends who mentioned that they just would just get burnt out if they just looked at code or did, like, yeah, they get burnt out faster. So I think what I would say is that you just need to, it's more about consistency over time than actually just spamming hours. So I know people who work 12, 13 hours a day. I feel like if you put in a solid 4 to 5 days of deep work, 4 to 5 hours of deep work each day, and do that consistently over 20, 30 years, you're that's already you're gonna get ahead of most people. Because even just putting that amount of time, it's more about consistency. But I was talking about this with a friend where, I mean, because he's new to Silicon Valley too, so he was seeing people are working so hard, and there's a concept of diminishing returns, right? After, pretend you work 8 hours, and then I work 12 hours. At some point, there's some diminishing returns, as in I'm not getting the same return on my investment for the more hours that I put in. But what we came to the conclusion was there's diminishing returns, but there's still a return. So if you put in 8 hours and you were able to pump out 200 lines of code, and I had to work 12 hours each day, and I was only able to pump out 250 lines of code, so only 50 extra lines of code for the extra 4 hours I put in. That's still a return, and compounded over time, like those diminishing returns, you still get a return. And people here don't care that there's diminishing returns as long as there actually still is a return, if you know what I mean. So that's an observation that we made. It's like everyone knows that after 8 hours you're kind of cooked, but that 4 hours you're still gonna get something out of it, and people are betting that that extra little bit is what's gonna be their competitive advantage or what's gonna take them to the top. So there's diminishing returns, but there's always a return. And the observation that we made is, I mean, people are always going to take that return. I mean, you could draw a parallel to the gym. Some people have a higher work capacity to volume than others. Yeah, the way I look at it is find ways. Just find ways that find what makes you different and ways that you're gonna have a competitive edge. Because at the end of the day, everything's a market when it comes to, I mean, the U.S., Canada. Everything's a market, including the job market. So you need to find ways that you're going to be a better candidate than the other candidates. So my way was I just knew that I had a high work capacity. So what that meant is I just want to study as much as possible, get as high as grade as I can as possible, and just pretty much outwork myself to differentiate myself in the market. So what would hard work get me? It would get me good grades. It would help me learn a lot of new things. It would help me send out a lot of applications and get interviews. But other people have different competitive advantages. Maybe they have a better network. Maybe they're just smarter than the average person, have a high IQ. I don't know what the other advantages are. But like maybe yours is consistency, having a good routine. Just try to find ways that try to find your strengths and lean into it. I mean, some people's strengths are going to be better than others. I still believe there's some sort of natural selection when it comes to there. If some people have better strengths than others, so naturally they're gonna rise to the top based on their advantages. So maybe high workload or work capacity is not actually needed in order to become successful. So if you have a high work capacity and you just grind, that might not lead you anywhere. You kind of have to get lucky that what you're good at or your natural abilities actually translate into being successful. But I mean, you can't control those things. So what I look at is I just look at what I'm good at and I just try to be better each day. Just myself, not looking at anybody else. And just try to improve myself each day and work to my strengths. I don't know if the strengths that I have will actually make me successful, but I know the strength. If I lean on my strengths, I'll be better version of myself the next day, and yeah, like the the better me has a better chance at the market than me suboptimally. If that makes sense. That's sort of my philosophy. That makes sense, chat? All right, we're gonna take a quick break. We got a bunch of, and I'm gonna hop into some coding interviews and stuff too. Don't worry, we're gonna get into juicy coding. How many? 2 people left, but I had a break in between because I was gonna do a challenge where I just did a ton of coding or I tried to do as many blind 75 questions in the span of an hour, but I mean, the interview with my friend went over. But I gotta take a quick break, and then we're gonna get back into some more coding interviews. But let me put on like somebody else here. Yeah, exactly. I feel like there's 2 people. There's just people who get stuff done, some people who are really smart, and then some people who have a high work capacity, and then there's people in the middle. Honestly, I wasn't really that smart because I didn't really pay attention in school growing up, and I didn't really focus on school growing up. So I knew automatically that when I went into university that I was disadvantaged when it comes to just being smart because I sort of neglected that in the early part of my life. I mean, my parents tried to force me to do well in school, but that wasn't really my thing. Paul, like the let's see what this one said. Arthur was good.
Yeah.
Classic right side, classic binary tree right side view. Just preparing some more lead code. Nice, nice. Are you coming on later? Do I have an interview with you?
Second question here. So I'll paste it up top. So take a minute to run through it, and then
Yeah, I'm
it
gonna
will
let
be removed, and the current node, I guess, the current node will be node will be 1. And then eventually Q will be this will be the only value here. So I'm going to be doing next. It'll be 2 and 3, but because num nodes at level is equal to 1, and then then the last is set to. So from what this kind of already iteratively going through it that way. So that's all.
Fair enough. Yep, I agree with you. I think that does make sense to me. Okay. I think you're spot on with that. So you did well with this. So let's do a second question here. So I'll paste it up top. So take a minute to run.
All right, I'm gonna go off for a second and let this run.
Run through it, and then for this one, similar to the first one, I'll give you an initial example, but I'll hope that you come up with more. That way we can do a triage for all of them, okay?
Sounds good, yeah. Given an array nums with n integers, your task is to check if it could become non-decreasing by modifying at most 1 element. So modifying. We define an array is non-decreasing if nums is greater than or less than or equal to nums I plus 1. Holds for every I, 0 base such that, yeah, okay. So from what this sounds like, non-decreasing, so it could also be even. We're fine with it even for the next value. So like something like 4, 4, 4 would be also true.
Yes, so in this case, it could be monotone, i.e. all values are the same, or it could be increasing.
Yes.
The only issue that we have is decreasing. So, we can use monotonically increasing or non-decreasing as synonyms in this regard.
Okay. That's an interesting question. Let me see. So, yeah, if we can, so for example, for 4, 2, 3, we can make this 3 or 4, and it would be valid. That's what it's basically saying. Or we could modify this to make it 1 or 2 for it to be valid. Or
in that regard. So let's note this. So what we want is increasing. Increasing is good. So we can say a couple of notes. Sorry, increasing, monotone, or a mix of both is good. So
Okay.
what we want here is 1, 2, 3, 1, 2, 3. We want maybe 1, 1, 2, something like that, or variants of maybe 1, 1, 1. Those are all fine for variable lengths. So so long as there's no drop, so long as for any given n minus 1 is not greater than it. That's the one thing we don't want to see.
Okay, interesting. So 1, 1, 2 is okay because it is non-decreasing for the two values. Okay.
Yeah, I'll also note, so to your point, if let's say we had a case like, let's say 3, 1, or 2, 1, 3, right? This is an example. The reason why this is returning true, so for context, any that is already in this condition, they're already non-decreasing. Already non-decreasing, right? So for this one here, the reason why we are returning true is because we can convert it by changing the values. What are options? So just think of one modification you can make to this to make it non-decreasing.
Yeah, to make it non-decreasing, we could make the middle one either 2 or 3.
Excellent. So we can make it 2, 2, 3. We can make it 2, 3, 3. Is there an alternative? Can you think of another option?
Yeah, the middle one, or the first one can also be 1.
Excellent. So we can also do 1, 1, 3. So all these are options, and this is why we say true. Reason being, we only need at most one modification to make it non-decreasing. And that's the condition. So it's either already non-decreasing or it only needs one modification. Any more modifications, and that's a problem.
I see. Okay, interesting. So yeah, it's for any 2 elements which can be made into, if we can modify it to make it non-decreasing, and we could I'm thinking about the algorithm, like it's sort of like greedily checking each possible adjustment that we could make, and if we can make at most one adjustment to satisfy that condition, then we can return true. Otherwise, if we need to make multiple, then we return false. And I'm thinking on the best way to kind of go forward with that. So if we have, for example, like 3, 2, 1, this, we could theoretically adjust this to 2 and it would work. Actually 3, 2, 2, 1, 1, 3. Actually, this would not work here. This would be false.
Yep, that is correct.
Okay, so we could be like, hey, we can turn from 3 to 2. We can do this, and that if we do this, then we are happy, but we cannot do it again. So then we return false. So yeah, I'm thinking that is something that we can definitely do. So likewise, if we have 3, 3, 1 initially, we can make this modification and to make it return true. So this would return true. Okay. I think that's how I'll approach the algorithm, like greedily try to make a swap, or not a swap, to make the adjustment for when the condition is not true, by satisfying it to make it at the very least equal to the previous value, because that will allow us like a possible range for the next value to be decreasing. Like if we, for example, do like 3, if this was like 3, 2, 1, and we do like 3, I don't know, like 5, 1, this also wouldn't work because this would be decreasing. So the reason I say that is because say this was like, if this was like 3, 3, like 3, 2, 3, like if we do 5, 3, then obviously this won't work. I think making it to equal to the previous value allows us to consider the next possible values and look at those specifically to see if it's possible or not. So that's why I think setting it to the previous value to set it to monotonic and then going through the rest of the array will allow us to check to see if it's possible or not. So that's sort of what I'm suggesting.
All right.
Yeah.
I think, yeah, you're on the right track with it. So let me just throw something your way. So input 3 here. I know we have other examples. So what if we had like this? So 4, 2, 3. So how would you go by this?
I see.
Just tell me the fix, yeah.
Yeah, for 4, 2, 3, this is decreasing and then increasing. So you would, right, for the first value, you would need to make it like 1 or 2.
All right. So in that regard, it's a bit of the opposite. We're not making the 2, 1. We are not making the 2, 4. We're making the 4, 2, right?
Correct.
All right. And then think about, let's say, what if we had a value like that? And I'll give you 2 options here so that you can explore this a bit more. So input 3, input 4. What if you also had now 1, 4, 2, 3? So it's a bit of a variant where this one here is greater than the 4, this one here, and the 2 there, and this one is less than the 2 here. So there's a little nuance to pick up there.
Yes, there is. So you need to compare the first 2, and if it's increasing, then it is okay. We just don't want it to be decreasing. So initially, it was 3. Initially, if it's 3, 4, 2, 3, then we can make this into, I guess this is going to be false. 3, 4, 2, 3, because this would need to be 3 here, which would lead to decreasing, or 4 here, which would lead to decreasing for the next one. All right. Wonder how we can approach this then. So if we look at this initially for 3, 4, 2, 3, and we look at the first value compared to the next value, it's increasing, and that's okay. But if you look at 4 compared to the next value, it's decreasing, which isn't good. So we want to correct that to 4. Like this is sort of what I was looking at earlier. However, the next one is incorrect, so you would return false. But in this case, it's increasing, which is good, but it's decreasing for the next one, which is bad. We want to not allow that to happen. So the way to fix that here, likewise for here, would be, so you could theoretically set this to 1, or I guess 2. 2 would make this work. So, okay, so maybe if you're at the middle, you use the minimum value of either. So if you're at 1 or 2, like for example, if this was like 9, obviously going to like 9, or well, I guess this wouldn't really work, but if this was like 3, setting it to 2 or 1 would both work. Let's see. This is 1, 4, 2. Yeah, if you're in the middle, either value would work because they're both increasing. So,
How about this? So, yeah, a little hint here. Don't worry, it's a light hint. So maybe let's try and organize your thought process. So I think for the size 3 examples, because I think the bit you're stuck at right now is you're looking at 2 comparisons. You stuck to the thought that we initially had. Let's still stick with the 3 comparisons as you're thinking about, because clearly you can see there is a relationship. So what if we looked at the window of 3? Are there patterns we can see? Like I'll give you an example. So this is the way I like thinking about it. So clearly it's a greater than, less than type of thing. Try and express the examples or the windows of size 3 in terms of, let's say, number 1, less than or equal to or greater than number 2, less than. So you can pick and choose whichever inequalities you want to use, number 3. Because we're only doing this for size 2. What about we do it in 3? Because as soon as we went to 3, that's where the problem started. So I'll give you an example here. If I was to pick, let's say, 3, 2, 1. So for context, the way I usually think about this is in terms of inequalities to avoid writing the and. So I can say this is num1, in this case is greater than num2, and num2 is greater than num3. So I can just simplify the expression like that, and that's strictly 3 to 1, right? And so in this case, I know this is false.
Yes. Yeah.
So why don't you build up inequalities here, and then let's ask ourselves, what kind of transformations can we do? That's the second question you can make. So can we change num1 to num2, and does that scale? Looking at our examples. See where I'm going with it?
Yes. So
it's just organizing your thought process there.
In this case, if this was say 3, 2, 2, it would be greater than. This would be. So in this case, because it's greater than or equal to, we could have true here. We would have true here because you have only one inequality, which is which you can fix basically. Likewise,
what's our fix? Maybe the question there is, what's the fix?
Given an array nums with n integers, your task is to check if it could become non-decreasing by modifying at most one element. We define an array as non-decreasing if nums I is less than or equal to nums I plus 1 holds for every I. I feel like you just need to check if you could delete anything and it was going to become increasing. Maybe you just need to know yeah, because it kind of needs to be it needs to be like you need something like this where it's going to be going up, but only in some portion. Maybe it goes up here, it goes down here, like where it's not correct. So you just need to make sure that so what you need to do is like just try to delete it. Maybe if it breaks, try to delete it and then continue. If it breaks again, then it doesn't work. Wouldn't it be just that? So just see when it breaks or when the rule breaks, and then just start to continue and try to make sure this is greater or equal to this, and then just continue. And eventually, you shouldn't see it break twice, as in this non-decreasing. I don't know. What y'all think? Let's see what this guy does. Oh, wait.
Particularly, how do we express it?
We express it by transforming the initial value to make it equal to n2.
Excellent. Or n3, either of them, because it can be equal, right?
Right.
Yeah. So here we say N1. In this case, N1 is going to be mid, N2. So this is the fix slash N3.
Yes.
And it's true. All right.
Yeah.
So keep going.
So in this case, if we do guess 1, 2, 1.
Yo, Alpha, did you send your code? Because once you send the code, I'll look at it.
This is less than, and this greater than or equal to. The fix here is twofold. It could be, you could increase one. No, the two fixes here could be, okay, so this is satisfied. It's greater than or equal to. This is satisfied. In this case, it wasn't satisfied. Or 3, 2, yeah. So in this case, this is actually less than. So, and this is actually greater than. So over here, the fix would be to have N1 set to, or have N2 set to N1, or N3 set to N2. And yeah, I'm just going to check this pattern here to make it work. So N3 would be set to N2.
All right, so let's see. So this is N1 less than N2. Does this tell us anything about the relationship between N1 and N3? Because I'm imagining this can.
Yo, chat, how do we feel about kids talking in the background? Are we letting that slide? I'm just trolling. We docking him for that? Not finding a quiet place? I'm just trolling y'all. Not for 200 an hour, find a quiet place? Real interviewer? Yeah. The thing is, as an interviewer, if there's noises like sirens and stuff, gets distracting, but I don't know. I feel like just solve the question. So I wouldn't dock. I'm just trolling.
Also express a pattern like, let's say 1 to 1 or maybe 1, 3, 2, right?
Mm-hmm.
It doesn't tell us.
It does. In that, like, N3 or N2 can either be N1 or N3. That's sort of what it's saying here. Like in the event where it's not equal, or it's kind of a peak here, or yeah, so if this was like say -1, the value can either, the value should be equal to that of N1 in general. If this was like a negative value, if it was N2, it would be increasing, which is, so N1 or N2. So that's the relationship. We can set it to the value of N1 or N2. So, yeah. So that's sort of what we're seeing here. So so for the first one, what we saw here is for 322, we can set N1 equal to N2 or N3, but for 121, we can set N2 to equal to N1 or N3. And I think we can sort of proceed in that way because that sort of accounts for all of the cases, actually, I feel, because we are going to be either doing two comparisons for if it's a value of two values of an array size 2, which we can fix, and we know we can return true. And
yo, they've been taught. No code has been written in 20 minutes. What's going on here? Did he just not figure it out? No. Like, I mean, like, in this coding interview that we're watching, no code has been written in 20 minutes. Yo, why'd you put it in C++? Is this it? If I equals 1 or nums I is greater than... Why do you have to look back here? Or nums I is greater than... Oh, I see. No, it makes sense. It makes sense. Let me finish. I see. Oh, I see. I see. I see.
For size 3, we're going to be...
Y'all think this candidate's gonna solve this question or what? I think, dude, this interview went way over.
We can fix either the first two, and then the third one will sort of automatically be adjusted accordingly. So that's sort of like how we can look for how many times.
Honestly, chat, when I first started conducting coding interviews, when I first started, a lot of them went 5 to 10 minutes over because I was just so scared to cut them off, and I just felt bad to cut them off. And they'd be so close, and I'd be like, okay, I'll give them more time. So a lot of my interviews were going over, but then it started messing with my meetings. I mean, it's not good to give candidates more time too, because you want to have it standard. So after, when I got more experience, it's like started just finding a safe place to stop it.
We need to fix this, and if it's more than once, we return false.
All right, this makes sense. I'm trying to think through. Okay, so this pattern here. So we have 1, 2, 1. Okay, so this one here, I'll imagine 1, 2, 1. Are you gonna return false or are you gonna return true? Just to understand this correctly. Huh?
Yeah.
Sorry?
For 1 to 1, I return true because you can fix it by changing the middle value.
Oh, okay. We had written false here, so I was a bit lost. Do we want it to be false or do we want it to be true?
We want it to be true. Sorry, it was false when I caught.
Oh, good. Yeah. And you said the fix is changing N3 to N1 or N2. To N2 particularly, sorry, right? And the problem with that is it candidates.
So it's true, which is fine. It's because I didn't sort of like draw out some of the different scenarios. It came to where like I was thinking more about algorithmically, more mentally, as opposed to these different N1 or N3. So mine
equals size 2. But if you have more than one inequality, the easiest way to express them is usually either the smallest to the largest or the
Alpha, it's not a good performance, not a great performance.
Largest to the smallest. So in this case, N1, we say it's greater or equal to N2. In this case, it's greater. And then N2 is greater or equal, not N2, sorry, to N3. And then you say N3, in this case, could be greater or equal to N2. And so this forces you to have an order. And so it doesn't deviate much. This is usually like a nifty way if you want to like write inequalities and then not.
Oh, he already did right side view. So it seems pretty solid. Implemented a pretty solid right side view. No complaints about that one.
Have to worry about extra ways the inequality could express other values. Does that make sense?
Yeah, that makes sense. Yeah.
All right.
And when
so we.
Yo, Paul, stop acting like you're having trouble getting interviews. You too. Like, I know you're able to get interviews, bro.
Yeah.
With this in mind, I think you might have most of the cases covered. Okay, I think this is good. You wanna take a stab at coding it if you feel like you understand it?
Yep. Let's see here. Let me take these cases here and put this here for now. I guess this is check non-decreasing. Public static Boolean check non-decreasing int of nums. Return true. So for int I is equal to, so we're
really?
checking.
Yeah, like, do they have more sweet rolls that aren't referrals, or sorry, that are? Do they have sweet rolls that aren't on the referral page? Honestly, I don't know anything about like what they're doing for hiring. Dude, the company is such a big company. Whatever you hear is what I know because company's just so big. Like we don't really hear things first. Yeah, that's what I know. Yeah, that's true because like I was one of my friends. I was referring them for an entry level, and I could either just send them the link so that they can apply, or I can refer them directly to a position. But when I would look for the position that they wanted to get a referral for, and it was an entry level, it wasn't. It just wasn't showing up. It's weird. Paul, apparently you could apply as long as it's in a different position. There's cooldown periods of like 6 months, but it's by the position. So I know someone who did a suite one and a networking one simultaneously. Yeah, like you can refer them directly to certain positions, or you can give them a link that lasts 12 months. But the one that like I can refer him for exact position, it wasn't showing that many positions that it wasn't showing the position that they wanted to get into. Honestly, I don't know how it all works. I'm still new in figuring it out. Input. Yeah. Yeah, they're probably, but like every year companies are gonna need to hire more usually. Then things will open up. Okay, wait. There's another guy that's okay. Where's the guy that I was supposed to join? ASD. I'm in the room. Wait, you're. I don't see you waiting. Does your first name start with a R? Cause the person joining starts with a R. see. Is your first name start with an R? Because that's maybe you're the next person. Yo, you're the next person after this rate. Like we have somebody up before you. I didn't even know. Like, do you have the link? Like in the link? Yeah. There's somebody on in 5 minutes. Though that's not you. What does it say on your link? Like on mine, it says you're at 9 p.m. my time, bro. Damn, sorry. I wish I could. 9 p.m. What? Yeah, exactly. Oh, you're trying to go earlier, huh? Yeah, it's specific. Just relax. Go get some rest. Eat some dinner. By the time this next guy hops on, you'll be good. Okay, wait. Just waiting for this next guy. Whoa, wait, what happened? Wait. Did I dip? Uh-oh. Yo, chat. Chat still working? Chat still working? Yo, got them. Waiting for the next guy to hop in. Just chilling for now. Test. Wait, let me test. Test. Nice. Okay, how do we solve this question? Yo, who's able to solve this one? Like one way is to just simulate it. Is to just brute force simulate it. Because the thing is, oh, what's up? Someone's hopping in. Yo, Raymond, what's up?
Yo, what's up?
How you doing?
Good.
Have you hopped on this coding interview stuff before, or is your first time?
Yeah,
Oh, really?
it's my second time. Yeah,
Which one did you do before? Let me find you.
I did like some tree problem.
Oh
It
yeah,
was like the one where the end degree was 0, something along those lines.
Okay,
I don't know.
nice. I see. All right, let's just get straight into this then. Sorry if I don't have my camera on because it tweaks out the stream. You don't have to turn yours on unless you want to.
All right, I just turn it off then.
All right, let me check what I have. 3, 2, 1. Hey everyone, so today I have a student from Florida is taking the Georgia Tech Online Masters and has solved 380 leak code questions, so quite a bit. Damn, you did a lot.
Yeah, I don't think it's enough though. Still not good enough, I feel.
Have you been getting interviews and were you able to pass them or just not able to land any interviews?
Still not able to land like the big tech interviews. I got like the Amazon OA
Nice.
before.
Chat's asking what class are you taking? You might be in the same class as one of these people in the chat.
Oh, I'm in the. I registered for the ML for trading class, and I'm on the wait list for like networking and the machine learning, the regular machine learning class.
Damn. Dude, I heard those. Have you taken any of the machine learning classes there yet?
No, this is my first
Okay.
semester
I
there.
heard it actually goes into some deep math. Like insane.
Really?
I don't even know.
Shoot.
But cool.
Yeah.
So what's sort of your goal? Are you trying to land a role in big tech? Just need to know so I can format this interview in the right fashion.
Yeah, I'm interested in like ML ops and like site reliability engineering, that kind of stuff. So just like I don't want to go too deep into ML because you kind of have to have like a PhD to like get hired, I feel
Mm.
like.
And you don't
So
want
I
to
just
just get into regular suite?
I want to do like distributed systems type stuff, like networking type stuff, like cloud computing stuff.
Yeah, I see.
Yeah.
Cool. All right. But in this one, you just want a regular coding interview? I
Yeah,
sent you
just
the
like a
link, by
regular.
the way. I sent you the
Oh,
link inside the Google Meets.
inside of Google Meet. Okay. All right. All right, I'm
Okay.
in.
Let's see. Let me just come up with a good question. What did I ask you last time? Related? It was around binary trees.
Let me see. Let me see the list. Oh, it was like validate binary search tree or something.
Okay, and
Some
it was the first question because usually that's my like in the second out of 2.
uh that was the first question.
Oh damn!
That
And then
was
we
the
just
first question.
did we just stick with that the whole interview?
Yeah.
Okay. All right. Okay, I got a different. I'll test different aspects right now.
It was validate binary tree node. It was that one.
I see. Okay. Yeah, I stump people with that one all the time.
Yeah,
Let's
that one.
see. So I'm gonna ask you 3 parts. There's gonna be 3 parts. Let's focus on actually getting through all the parts. They're gonna get slightly harder.
Okay.
So I'm gonna. What programming language do you want to use?
Just Python 3.
Cool. So part 1, we're doing some basic string processing. Write a function that takes a string containing only lowercase letters and returns the length of the longest substring that contains the same character.
Longest substring that contains the same character. Okay. And just write in here this function.
Yep, write a function to do that.
Okay. Thinking use a default dict from collections import default dictionary that counts the number of the frequency of the characters, and we keep track of a max count variable, and then we return that at the end, basically.
But what's that gonna return to us? Just
It's
it's gonna turn us the most frequent.
the
character.
length of the. Yeah, we it's gonna return the length of the longest substring. We keep track of the length of the longest count, or like the maximum count within the default dictionary. So like for the first one, the dictionary would look like A2 and like B3, and then we'd return 3. Takes in a string.
What if we had something like this?
ABA?
This.
It'd still return. Oh, okay. Okay, so. Oh, it has to be contiguous. Okay. Thinking maybe do a sliding window then. Sliding window that, yeah, the window keeps expanding until if it's the same character, and if it's a different character, it resets to 0 and starts expanding again. So sliding window is expanding when we have the same character, and resets to 0 when we change to different character. And we keep a maximum window, window length, count length variable. Expected indent. Okay. What?
Okay. Makes sense.
No.
I mean, go ahead and
Okay.
implement. Yeah.
So we do a for loop through all the characters, and current character be a variable. So the string size is at least 1, right?
It could be empty.
At least 1. It could be empty. If not, if it's empty, we just return 0 for that case. Keep a current index as well. Less than, do a while loop. Well, it's less than that. Equals. Keep a count of the current window size.
So what are you thinking here?
So we have a variable that keeps track of the current window size count, and then we're going to loop while it's the same character. While it's the same character as the next character. Huh. Same character as the next character or previous character? We'll do previous character. Actually. Do previous character actually. Start the index at 1. And current window size, we increment the current window size by 1. And when we exit out of the loop, we set the max window size again. Max window length. Or no, current window length. So, okay, so this is keeping track of the case when the string is empty. This is iterating through the entire string. Keeps track of the current window size. This is continue looping, increasing current window size if it's the same character. We have to increment index here. Current index.
Do we need this current window size if we already have the index? Or no? Okay, you're not keeping track of a left and right. You're just keeping track of some.
Yeah, we could do the left and right, but I think this might work though.
Okay, do a dry run for me. Once you get it working. Let's dry run it on this code right here. A, B, A, B, B, B. You show me how it's gonna work here?
Okay. Like
Dry
okay.
run.
So it'd be 1. The max size would be 1 because of the A in the beginning, and then we reset the window starting with the B, and then we reset it starting with the A. And since they're all a window size of 1, we don't change the max window length variable at all. And once we get to the B's, the window increases from the first one to the second one to the third one, and then we at the end we keep track of the max. We update our max window length variable to 3, and we return 3 at the end.
Can you dry run me line by line the code, and then yeah, dry run it and refer to the code.
Oh, okay. So we check if it's empty. It's not empty, so we go to the next one. Current index is we're currently on 1 here.
So you're putting the current index here right away?
Yeah, because
okay.
I want to check the one in the past.
Okay.
The previous one. So it's different. So it's different from A. So this while loop doesn't run. Oh, and we have to update the character. We have to update the character. We have to update the character. Okay, so we update it to update to 2. Iterate through the entire string.
Okay, we have it at 2. Then what?
So we have it at 2, and then we check if it's the same character, the previous character. If it's the same one and it's different. So we wait. We might have to increment the index outside as well. So we update it to this one, 3, and we check if it's this. I don't think this is going to work. I think we might have to do the left and right pointer.
What's the left and right pointer solution?
We don't have to keep track of like the max window length. We can just subtract right minus left and then +1 for the window length. characters. What if wait. A little bit stuck here.
So what do you think? You have the left pointer for R in range S. So what does the left pointer and the right pointer, or what does the left and right pointer represent?
It represents the middle. If I get to a new character, I guess I set the left pointer
So you have
to
a
the
left
right pointer.
You have a left,
Left pointer to the right pointer.
Yeah, like it'll help if you visualize it here. You start L here, and then you have R, and then just see how it's gonna behave.
So I'm going to draw it out here. So we have A, B, A, B, B, B. Left and right pointers here. First iteration. Let me see. I'd copy this. I'll copy this. Oh, that's how I copy this. Okay. So this is what I'm thinking for the code.
Wait. Okay, wait. Just
So-
come back over here onto the drawing. I'll give you a small hint. Let's see.
Okay.
Or yeah, we could just imagine what it's looking like here. Well, like I see that you know that it's a sliding window. It's more just implementing the sliding window. But like honestly, I think even sliding window is probably overcomplicated. Maybe you just need to know what the element was before it. So if A is for it, maybe you have like a count or something. Right? Or starts at 1. It's like and then you reset this count back to 1 if it changes, or you increase it. So B, that's 1. B, if it's the same, you increase it. Like could you explore just using one variable maybe and looking only one behind?
Yeah. If we look one behind.
And just like have a count?
Yeah, we could do that. Oh yeah. But if we're gonna have to look behind, we're gonna have to start at 1 again. It's kind of what I was doing.
Yeah, if we look back and if we look back one character and it's different, then we just reset to 1. But if it's the same, we increase the count and maybe store some global result.
Yeah, that's kind of what I was doing previously.
Yeah, but I don't
Like
think you'll need
here.
a 2-pointer there.
Yeah, okay. It's kind of what I was doing here. if the previous one is equal to current character. So we have a variable that keeps track of current character. The window size keeps track of window size, keeps track of the current character, and keeps track of the current index.
Okay, let's move on to a tree question because I wanted to get into trees also.
Okay.
Come back up over here. Okay, I'm gonna post the next question up here at the top.
Given the root of a binary tree, return the length of the diameter of the tree. The diameter of the tree is the length of the longest path between any two nodes in a tree. This path may or may not pass through the root. Okay, let me draw it out really quick. How do I... So we're returning the diameter of a tree.
Yeah. I'll give you an example just to make it easy for you. 1, 2, 3, 4, 5. So we're given a binary tree. We're going to be given the root of a binary tree. So this guy, this root. So what the diameter of this binary tree is 3, because there's 3 edges. So I'll highlight this. So it's like, if we go like that, that's the diameter of this this one.
Oh, but
right? It doesn't need to go through the root though, because for example,
okay.
It doesn't. For example, we have like other one here. The top diameter is this one, I think. I mean, this one's also 4, but if we added one more, there might be. Right.
Okay.
Like there. 2, 4, 5, 6. Yeah, exactly.
So we have to use recursion.
Do you know what I mean by diameter?
Yeah, the longest length from like the left tree branch to the right tree branch.
Yeah. Like between two leaf nodes, the longest path.
So we're gonna have to use recursion because it's a tree problem usually.
Mm-hmm.
Usually we do recursion. I'm thinking that we count the length of the left branch, like the depth of the left branch, and then we count the length of the depth of the right branch. So this would be 1 here, 1 here, and then we'd max the left and the right, and we return that. We pass that back up here. The max is still do max plus 1 because we have to count the node that we're currently at. And then we pass that back up to here. So it'd be 2, and this would be 1. And then
Oh, you cut out? Or you're just thinking, my bad.
And then we'd get 3 here.
Yeah.
But would it work if it was in that scenario we're talking about? We'd pass one up here, one up here. It'd be two here, and then it'd be three here, three here. But it'd be four here. We want the left. Oh, we want the max of the left. Wait. 1, 2, 3, 4, 5, 6. So we want to return 6 here because it's 3 up and 3 up on the left and 3 up on the right. How do we keep track of the 3 though here? They're the same.
What was your question?
Like, how do we keep track of the 3 here? Like, if they're the same length? That's what I'm stuck on a little bit.
So, what do you mean by keep it? As in when you're returning it?
Yeah.
Well, does it matter which one you choose? They're both 3, right?
Yeah, true. Oh, yeah. Wait. 1, 2, 3, 4, 5. Because I was thinking of that about this logic, but it wouldn't really work. Like max of left and right.
That's where returning up. But I'll give you a hint that, yeah, that's probably correct for returning up. But at each node, you want to see, like at each node, you also want to see if you can get to the max, like the max length through that node, if that node is the root of that answer. Does it make sense?
At each node, we have to figure out if it's the
Like
answer.
it could be the answer, right?
It could be the answer.
Because this one is the answer.
Oh.
Right?
Yeah, okay. So okay, so I guess we can have a variable on the outside that just keeps track of like left plus right. The length of the left, depth of the left plus the depth of the right. Answer is, I guess the answer is just that. The max of that. Okay, kind of get it now. Start implementing it.
So what are you gonna do?
I'm gonna keep like a global variable.
Okay, just go ahead and implement
for the
it.
answer. Okay.
Yeah.
Do I just okay. Tree diameter. Answer equals 0. Depth first search. If it's not, if it's the return 0. Return left equals defs root dot left. If left. If there's a left node available. If there's a there's a right node available, we do DFS root dot right and turn 1 plus max 1 plus max of left and right. And is that it?
Let me see. This thing looks legit. Let's see. One sec. Just verifying. Yeah, looks legit. It's working. Okay.
Ooh.
Nice.
So I was a little bit confused on that part, like how to keep track of the answer.
Yeah. Let me think. Is there a follow-up I can give here? You want to try finishing Q1 or you're good?
I'm good.
All right.
Let's do another question. Okay.
So how do you think you did? How was that?
Huh? Oh, I
Yeah.
think I was struggling a lot with Q1.
Yeah. Was
Maybe I should go back and solve it.
let's see. Where
don't know.
was it? Let me look.
All right, I'm gonna go back and solve it.
Okay. Try it for a little sec. Let's see. So what where were you having trouble in Q1? Where were you getting stuck?
I think I was just like I was trying to like code it up, even though I don't like fully understand like exactly how to solve it. So
Yeah.
I'll walk through it like step by step, and then like once I fully understand how to do it, maybe I should start, and then I should start coding.
Yeah, exactly. So for that one, yeah, you kind of hopped into coding like before fully understanding the question.
Mm-hmm.
I think you thought your initial attempt was like count out the one with the highest frequency and return that. Right?
Yeah.
But yeah. Your sliding window, so okay, basically going back to that, just make sure that you understand the question before you implement. Sometimes it looks easy and then you realize that you went the wrong direction and you don't want to spend any time doing that, and also it's a negative signal in the interview because you got ahead of yourself essentially. So just make sure you understand it. Second part is your sliding window code isn't clean. So yeah, I think you just need to understand that sliding window is like a boilerplate code. So once you implement it a few times, you'll be able to just boilerplate it. So I'll show you how to do that, but the other piece of feedback was just with the dry running. So when you dry run, you should also refer back to the code. Pretty much what they want you to do when they say dry run me your code is literally step line by line through the code, explaining each line and how it works and how it affects the solution. And then usually at the same time, I'm sort of simulating what the input in the, or like I'm simulating my variables to show them like how it's changing over time based on the code. So you basically have to act like the compiler of the code.
Oh, do you just like type it out like, or like do you just say it, or like what do you do?
Usually I say it. So for example, I'll give you an example here. Pretend we just need to track. Let's talk about this sliding window, right? We just need to keep track of the way I like to do is you keep track of a left and an R. So what I do is to simulate that is put L and R here, and we'll say left and right, it starts at 0. Then we want to keep moving. Was it the right pointer up? Move the right pointer up while it's still the same value. So we'll do while r is less than the length of s. I want to write this out because I want to show you the boilerplate.
Okay.
But basically, what we'll say, it's like if we'll have some result here.
This is Cadane's algorithm, right? Or something like that.
I don't know if it is Cadane's algorithm, but what we're gonna do is take the right pointer. So you see how I'm like simulating and talking about the code. So while result equals 0, while r is less than the length of s, what we're gonna do is less than, or should it be less? Should we start at the second element or the first? See, the edge cases are always trip it out. So
yeah.
So what we're gonna do is while, basically we're gonna move up the right pointer, and then we're gonna have a while loop right here. This is how I usually do it. So, and then we're gonna capture the result here. So literally what happens is, yeah, you go r+1 while r is less than maybe length of s, and left is less than right, and but the thing is, you don't really need to do this one with a sliding window. You just need to track the one before. But like, even I'm messing up the sliding window template right now, but this is usually how I do it. Something really like this, like while r is less and length is r, and some condition here to do s, right?
And for the interview, they usually like tell you to run some test cases as well, usually.
Yeah. Okay, so this is kind of the boilerplate model, something like this. And
Oh, okay.
left plus equals 1. It's literally like that. Usually you increment here, and then you move the left pointer in some condition, and then when the condition is complete or it's not broken anymore, you get out of it. Like, I have a video on sliding window. I don't know why I tried to explain it real quick, but like, because I'm cooked right now too. Not dry. Yeah, I think overall though, you solved the second question pretty good. Yeah, that's sort of my feedback. You solved the second question. Yeah, that was good. No feedback on that part. It's just understand the sliding window. Understand, like, just get better at working with indices. So I think with the string, like the tree stuff you got down, just do a little bit more string problems. I can send you some good ones. Have you been on have you seen the Peralta 75 list?
Yeah, I've been grinding through that
Oh,
list
damn.
recently.
Nice. That's sick. But yeah, does that make sense? The feedback there?
Yeah, that makes sense. I kind of just like try to code it up even though I didn't fully understand the problem, which is bad. Probably
Yeah.
should have read it and like understand it a little bit more before I tried to code it up.
Yeah, and the line by line, like dry running, because candidates would, instead of what they do is they're like, oh, the input is gonna do this and the input's gonna turn into that. Like, if I was just simulating, oh, I'm gonna move this pointer up, and then this one right here, and then the code's gonna do this, and then the code's gonna, like, I still wouldn't believe the person's algorithm worked because they're not even referring to the code. That's why when they say, oh, I'm gonna move the right pointer, then they select, oh, this is where we move up the right pointer, and the left pointer is moving up because of this code. You know what I mean, like, actually showing how the code works and explaining that's a skill that you need to have for the interview.
Okay, yeah, makes sense.
All right, cool. Thanks for hopping on. Let's hop on again soon. Continue grinding.
Yeah.
Thanks for coming on.
All right,
All right,
thank
see
you.
ya. Bye.
See ya.
Okay, we got the last guy on. Ashman, hop on. Let's get it. Yo, Ashman, what's up, man?
You can hear me?
What's up? What's up? How you doing?
I'm doing good, man. How about you?
I'm doing good. You're the last one of the day. Thanks for tuning in. You saw like all those guys. All the
Yeah,
ones
I mean,
before.
I thought it was like Eastern time, so I was like waiting for the 9
Yeah,
p.m. thing, but it turned
yeah.
out to be Pacific. So.
That's so funny. Oh, you're on the east?
Yeah, I'm on Eastern right now.
I see. Cool. Thanks for hopping on and doing the coding interview. From what all I know about you right now is you solved 100 leak code questions and you're based in the US. Is there anything else you'd like to share, like what school you go to or?
Yeah, I mean, I just completed a master's from like a small state school, and then also I'm prepping for interviews. So like I have an interview coming up, so I was just working on stuff. Yeah.
Nice. So
hmm
how long have you been working, or are you a student?
So I've been working for about like around 3 years.
Oh wow, you've been okay. So you've already worked, and then you went back for your masters, and then now you're graduating.
Yes, I was doing like masters, and I was also like working as well. So.
Nice. What area, or sorry, like are you a SWE right now?
Oh yeah, yeah.
Okay,
I'm
cool.
I'm like I'm doing like technically I'm doing data engineering stuff right
Yeah.
now, but like the official title is still well like yeah, software engineering basically.
So how are you at leak code? Are you pretty good?
I wouldn't say I'm that good. Like I still have like a lot of areas to work on. Um, but I'm trying to get better though.
Hmm.
Yeah.
So because yeah, you only did 100, so I don't know how hard of
Yeah,
a
so
question I can ask.
that's actually not fully true. I've done more than that. But that was like a long time ago when I was doing my bachelor's, which was like around like 2016, 2020.
Hmm.
But then I stopped because I was just working, and then after I started applying again, I started doing a bit more. So like the 100 is basically what I did maybe in the last year.
Nice.
So like like I know the general stuff, but I'm still not that confident because, for example, if it's not a problem that I've seen before, or if it's like a very hard problem, or like if the pattern is not that obvious, then I probably won't be able to solve it
Okay.
in an interview, especially under time pressure and all that.
Yeah. How like what language do you like to use?
I use Python for interviews.
Okay. And is anything not fair game, as in that I just shouldn't ask you, like DP or something?
I would say like since I have the interview coming up, I would say like let's do everything fair game because I probably that's how the real thing is going to be. So
Is it a company known to use DP?
is it's Amazon, so
Okay.
I don't think Amazon uses DP that much, right?
Yeah, I'm not sure. Okay.
I I've heard they don't use it that much, but
Sounds good. Okay. I got some good questions.
all right.
Let me bring up the first one. All right. This is a super popular Amazon question, so
Okay.
whip this up on here.
All right.
So we just want
Okay.
to generate parentheses, well-formed
Yeah.
parentheses.
Mhm. Given n pair of parentheses, write a function to generate all combinations of well-formed parentheses.
Exactly.
Okay, so like you can do you see when I highlight stuff?
Yeah, I see when you highlight.
Okay, okay. Yeah, so I think valid parentheses or well-formed would be just like something. If something is open, then that has to have some sort of like close, right?
Yeah.
Okay. So maybe like if I see a opening, there's three open parentheses, and there's two that would be invalid.
Yeah.
Um, I probably want to use a stack here. So maybe in my stack, if I put the open parentheses like this, and then I see the close, then I can just pop that one out, both of these out. And then I see this again, I can pop that out, but I don't have anything else remaining. So that probably means it's not a valid parentheses. Is that a good estimation, or is there any edge
Well,
cases that
we
I
don't
might?
need to print if it's valid or not. We need to generate all of the valid ones.
Oh, my bad. Okay, so it's a different question. My bad. Okay,
Yeah.
all right. So given n pairs with the write a function generate all combinations of well-formed parentheses. Okay. All right. So yeah, this is a bit difficult then. Yeah. So if n equals to 3, so this is the output here. So if I'm thinking in terms of like the sort of choices that I have, are probably, let's say, obviously I need to start with since it's well formed, right? I need to start with the opening, and then I can either close that or I can open another one. So I close that, and then another one would be to just open another one. Um, and then we can do that like 3 times, maybe. And then so here as well, I have two choices. So open, I close that one, or I open this one, and then am I thinking on the right track? Like trying to like see that there's like two choices that you can make at each step.
Yeah.
Okay.
Yeah, there's different choices you can make at each step. What are the choices?
You got a cut off there.
Wait, can you hear me?
Yeah, I can hear you now.
Yeah. So you said we're gonna make two choices. What are those two choices?
So what I said was basically, if I open a parentheses, right, I can probably either close it or I can open another one.
Yeah.
But I don't know if that captures all the cases, because it could be something like
Okay.
uh,
So
open,
makes
open, open,
sense.
close.
Makes sense. I think I agree with that. So you make two choices. You can either open one or close one, but you could only really close one if you haven't
Uh-huh.
if you have enough open. So you could just kind of make some conditional there. But how are you actually gonna generate all of these parentheses? Like what algorithm?
Yeah, that's a good. Yeah, so what I'm thinking is something like a recursive approach. So like this would be my path basically. So I'll probably have like a function that recurses, and then I would call that. I would add something. I would add something to the path. So that would be how I would make the choice. So, yeah, but I don't know if this is the right way to solve this. So let me just think about it more. Given n pair of parentheses, write a function to generate all combinations of well-formed parentheses. And open, closed, open, closed, closed, closed. Okay. Um. Yeah. So probably something like what I said before. So let's say I open this, I can either close that or I can again open another one. But I need to track all of this in my recursion. So
Yeah. I think you're going the right approach.
uh,
Go ahead and just try implementing it. And
Okay, sure.
yeah, like maybe
Um,
you it might jog your memory once you start coding to see.
okay. Uh,
Chat's asking when's your interview.
it was supposed to be like a week from now, but I think it's gonna shift because they kind of changed the teams up. So I'm kind of glad because I need more time to practice, especially like I need to like practice system design.
Yeah. How far can they push it back? The interview.
So I have a call. I have a call tomorrow, so I'm gonna ask them at least like 2 more weeks.
Okay.
But I don't know if that's enough
Yeah,
though.
we'll talk about it.
Yeah. Okay. So generate parentheses and then the recursion is probably going to be something like this. Um, so if I if I close it, I probably need to decrease the count of parentheses that I have remaining. But sorry. Can I go back to the drawing board and try
Yeah.
to figure
Go
this
ahead.
out?
Yeah.
I,
Yeah.
yeah, I don't really have anything like. Okay, so I need to generate all the parentheses that a function to generate. So basically, if either with this, close it up. So that means one. Um, so I think maybe this works, but I'm still not too confident on if this is a good approach. So what I'm trying to think is like what sort of state I need to track to be able to solve this. Because like what I said first was like if I started, I can probably do two choices, right? But I also need to know like how much. So for example, in this path, I've already finished this one of the parentheses,
Yeah.
right? So I'm just trying to think like because I also need to track that because this tells me that I need to uh, like I have like one to close one to close, and then one more that I can open and close, so on and so forth. So that's why I'm trying to think of maybe keeping track of something like the number of open parentheses and then the number that I've closed, and then using those states to see like what the total number of completed are. And then if the total number of completed is less than n, then I can probably keep on going. Is this in the
Yeah,
right path, or I'm?
yeah, you're going down the right path. I think you're just having trouble understanding what the recursion tree is gonna look like, or how you can do
Yeah.
recursion.
Do I need these states though? Like, is that overkill? Like the open close.
Yeah, you need to maintain some of the states. Like you need to
Okay.
know. The small hint I'll give you
Yeah.
is maybe try visualizing it as a recursion tree like this. So maybe
Yeah.
you
Yeah.
said we make two decisions, either open or close.
Yeah.
So pretend we open,
Mhm.
and then what happens here?
You can either like open another one or close the previous one. Like you'll do both of those, I think.
Okay, you want to go both,
Yeah.
right?
Yeah.
So what's it called? Pretend n was 3.
Uh-huh.
Okay, what happens here? What decision can we make here?
So you started your you probably need to open another one, right?
You can
You can
open
open
another
another.
one, and you can close it too if you wanted.
Yeah.
Okay, what about here? What decisions can you make here? If n equals
Um,
3.
yeah, so we would keep on sort of doing this until we ran out of, you know,
Yeah.
we completed. Yeah.
So at each level, you need to know n.
Yeah.
Okay, and then what other information do you need to know? Like you mentioned it earlier.
Yeah, like I said, like you probably need like the number of parentheses that are open, and then
Okay.
yeah, something like that.
Could
Yeah.
you pass? Yeah, just would you be able to just? I agree. What happens if
Okay.
what does num open do? Like what do we understand with num open?
So with num open, let's say this was already closed. Like num open basically means I need to close that as well. So that means like that's how many like closing parentheses I need.
Yeah, exactly. Basically, if
Okay.
num open is greater than 0, you can close it.
Oh yeah,
But then
yeah,
when
yeah.
you pass down to the children, you should subtract the num open because you closed one earlier.
Yeah, okay. Okay. Okay, yeah, I think this kind of makes sense. Yes, so okay. So at the start I have like my n equals to 3, and then the number of open parentheses is 0. So I start off with just the opening parentheses. Now when I send my state to my child, I'm going to say I have 1, and then um so that means since I have 1 num open, I can close it, and then I can also add another one. So in this case, num open would be num open would be 2 in this case, and then in this case num open would be 0, and then num would be 2, because I can work on 2 more. Yeah, I think this makes sense. I think this is what I need.
Okay, go ahead and implement.
Okay, so let me okay, so I have the n, and then I'm going to say number of open. So the base case is going to be if n equals to 0. Uh, I'm just going to use like variables because like I don't want to like deal with like trying to do this with just like returns. I'm
Yeah.
gonna
Yeah.
not be able to do it right now. Okay, so if n equals to 0, that means I have completed everything. So on my path list, I'm just gonna paths list. I'm just gonna add the path. And then if num open is greater than or greater than 0, then I can generate parentheses with n minus 1 and probably the same number of open parentheses. Oh, sorry. And then minus 1 num open, and then path plus close it. So if in the normal case, I'm just going to say pass in the same n and then num open plus 1 and then path plus open 1 more. Okay, so I'm just going to try to dry run this scenario, see what happens.
Sure.
Okay, so for n equals to 3, we have n equals to 3 num open. Let me just say 3 0 and then empty. So at the start, if n equals to 0, no, so that's just skipped. And then if num open is greater than 0, that's also skipped. So generate parentheses n3 num open plus 1 because it's open 1, and then we just add this to the empty. So I'm just
I
gonna
mean,
follow this.
feel free to actually just run the code and see what you get.
Okay. 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 Let's see.
Like debug by just running the code.
Yeah, I can do that. But that's not like allowed in interviews, right?
Depends. In Amazon,
Okay.
you can.
Amazon,
Maybe. No, I don't
they
think you
don't
can.
really run the code. I think like
Yeah.
they just do. You just have to do dry runs. Uh-oh.
You're in an infinite loop, I think. Yeah, you're in an infinite loop. It's probably this
Okay,
one.
so yeah, but yeah, most likely this. I think probably. Yeah, so when I open something, when I open something, I probably expended that, so I probably need to subtract that here. But in this case, I probably don't want to do it. Let's see.
I think there's still infinite loop.
Yeah. Okay, let me just think about this. So if n equals to 0 plus oh, holy crap.
So what are you trying to find now? Like, why is it looping? Infinite looping?
Oh yeah, that's what I'm trying to figure out.
Oh,
That's
look
what I'm
like
trying to
it ran. Oh no, it halted.
Yeah. So
I think it's your code there looks good. Or how is this
yeah.
gonna help find the issue here?
Yeah,
Or
so I was just trying to dry run it because like I can try like printing stuff and then
yeah.
like try to figure out where it's wrong. But if I actually like fully understand the code, like probably will be better to find the bug. That's why I was doing that.
Okay.
But
Like
I feel like it's probably close to the solution. I don't know. What do you think?
yeah, I think right here you just need to return.
Oh no
Because
way.
what's happening is it was
Oh
going
my
through
bad.
it.
Yeah, that's God damn.
Okay, this is
Yeah,
what
but
this is it's
sorry.
returning something now. Doesn't look accurate.
Yeah, it doesn't look accurate. So it's returned for 3. It returned 1, 2, 3, 1, 2, 2. Yeah, there's still some issues here. So it looks to me like all the open parentheses at the end are not getting closed. Like this has like 2 at the end and then 1 at the end. This has 1 at the end, but the rest are getting closed.
Okay, let's just try a
There's
smaller
1.
number. Just 2 parentheses. Sorry.
Okay. Should I try to solve? Should I try to resolve this?
Yeah, try to resolve it.
Okay.
You
Okay.
want to test your debugging skills.
Okay. Yeah. So what we have is path, and then if n equals to 0, pass it up and path. If num open is greater than 0, um, we're saying pass the n. Um, two, 0, 1, 1. Good. It's going here. It's closing that, so it's setting n to 1.
Well, if n equals 0,
Yeah.
what if we still have open paths?
Yeah, maybe. Yeah, I think maybe that's the problem. So here 0 is n, and then 2 is the number of open, and then we still have that open, right? And here as well we have this. So probably for
Oh,
maybe it's working now.
yeah, it looks like it's working.
Oh, wait. Let me delete this. Sprint final thing. It looks like it's working. Nice.
Nice. Okay. What if I wanted to generate it? What if I wanted to generate the parentheses for also curly braces?
Yeah. So probably like probably just like pass in a like type or something.
Okay, wait. We're gonna move on to one last
Yeah.
question, cause yeah,
Yeah.
you pretty much got this.
Okay. Okay. Yeah, this was kind of scary, man. Like this kind of nerve wracking. Like this is good though. Like
It's what you
because
need,
I feel like
man. It's what you need.
if I was doing this on my like own, I feel like I would like it would not have been this hard, but like just the fact that like, but I think this is good preparation for the interview though.
The next question. I'll let you go ahead and read that.
Okay. So you're given an m by n grid where each cell can have one of three values, which is 0 representing an empty cell, 1 representing a fresh orange, or 2 representing a rotten orange. Every minute, any fresh orange that is 4 directionally adjacent to a rotten orange becomes rotten. Return the number of minutes that must elapse until no cell has a fresh orange. Sorry. So this is an m by n grid, and then we have three possible values: empty cell, and then some fresh oranges, and then we also have rotten oranges.
I'll give you an example.
Okay, okay,
So the output
okay,
of this should be 4.
okay.
Do you see why?
Yeah, so let me just read the question. So I'm given a m by n grid where each cell can have one of three values. 0 represents an empty cell, 1 represents a fresh orange, and then 2 represents a rotten orange. Every minute, any fresh orange that is 4 directionally adjacent to a rotten orange becomes rotten. So so in the first minute, basically 1 and 1
Yeah.
got rotten, and then second minute probably this and this got rotten, and then this and this got rotten.
Yeah.
But how does that make it 4 though? Isn't it supposed to be 3? Like so first minute like
Just put 3 right. Oh yeah. No, because
is it 3?
like the first one it spreads to these two, right?
Yeah, yeah.
Second it spreads to these. Third it spreads to
Yeah.
this guy. Fourth it
Oh yeah,
spreads to
third
this guy.
this guy. Okay, makes sense. Yeah. So okay, so okay. Yeah. So what I'm thinking of is like like where are the rotten oranges? Where are all the rotten oranges, right?
Yeah.
So if I had a rotten orange here, then in the first minute, this would also be rotten, including this and this, right?
Mm.
Um, so let's say I have like all the indices of the rotten oranges prepared. And that could be like a bunch of different indices, and then I can say in the first minute, all what is- 4 directionally adjacent gets rotten. So that gives me an entirely new list of like new rotten oranges, and then I take that list. So this is basically each minute. Like this is so this is minute 0, and then this would be minute 1, and then minute 2, and so on and so forth. So I think this basically amounts to like a breadth first search
Mm-hmm.
from all the rotten indices.
Yeah.
But what's written the minimum number of minutes that's was allowed on the nose cell as a fresh orange. If this is impossible, return -1. So in that case, if let's say I turn, let's say this was a 0, turn this into 2, 2. So after I do this operation, right?
Yeah.
This maybe I can do like a iteration through the grid and then try to find the count of non-rotten oranges, fresh oranges.
Yeah.
And then if there is any, like I can say it's impossible.
Yeah. Makes sense.
Okay.
So what you're gonna do? Breadth first search, you said?
Yeah, I think I'm leaning towards a breadth first search. Is that a good
Okay.
idea, or do you
Yeah.
is
Go ahead.
okay,
Makes sense.
okay. All right. So def. Oh. Uh, no, let's just call it like rotten orange. I should just mm, um, if grid of ij is rotten, then yeah. So 0, 0, 1, 0, 1, 1. So, okay. Yes. So once I find the rotten oranges, I basically have my first level. Maybe I can start up a new queue, and then I'll basically say for probably say what are all the directions I can go, and then go up. Um, so um, for okay. I Yeah, so for each of the indices in the queue, and then for each of the directions, I have to calculate the new direction that I can take, which is going to be I plus dx and then j plus dy. And then if uh, di is greater than or equals to 0, and then is uh, it's not equals to zero. Yeah. So check if it's a valid. So check if it's a valid index. So if it is indeed a valid index, then I just put it in the new queue. But actually, do I need to? Yeah, so I have a list of oranges, and then I check all the directions that I can go to, and then what am I doing here? One second. So I got the list of all oranges, rotten oranges, and then so four. Go back to the mix, and then yeah. So if that is a valid index, and then j equals to 1, then uh, now that gets rotten, and then I add that to the queue so that I can explore. What else do I need to do? Yeah, so I add that to the queue, and then
For queue, are you using a queue or just a regular array?
oh yeah, this is just I'm just calling it. I'm just naming it queue, but it's just a regular array.
Okay.
So yeah. So now the queue is going to be the new queue. Okay, so let me just like run through this just to make sure if I have it right. And then I probably also need to increase the minute here as well. So okay, so I started off with like an empty queue, and then what I did was I just iterated through the grid, and then I collected all the rotten oranges, and then that's my starting point for the BFS. Initialized a variable to track the number of minutes passed. I just created this as like an easy way to represent
Yeah.
four directions. And then while we have something in the queue, I just started this up to like represent the new level.
Mm.
And then for each of the indices that I have currently in the queue, I just calculated the directions that I can go to, which would be the current direction added to the change, and so on and so forth.
Yeah.
And if that is a valid index, which would be, let me see if this is right. 0 is less than or equal to di, and then yeah. So if that's a valid index, and then if that is a that is a fresh orange, then we probably need to make that a rotten orange. So I did that, and then since it's rotten, I can add that to the new queue, and then I just said now we're operating on this new queue. But where do I say that a minute has passed? So probably we'll do that here. Okay, so minute was passed, and then now finally what I need to do is uh, so the question is, the minimum number of minutes that must elapse until no cell has a fresh orange. If this is impossible, return -1. If grid ij equals to 1. Yeah, I think this would be my solution. Do you want me to run it, or like do you have any like concerns about it?
Yeah, sure. Run it on there and let's see what it gets.
Okay, let's see.
Gotta fix this.
Okay. Okay. Print. -1. That's correct, I think, right?
It should be 4.
Because there's no rotten oranges,
Oh, yeah,
right?
yeah.
Yeah.
Put it 2.
Okay. All right. Oh shoot. Okay. So 2. It still returned -1. Okay. So directions. Blah blah blah. Let me check what's in the queue at the start. Print queue. Okay, that's good. And then let me see what is in new queue. Sorry, new queue. So it should be this and this, right? Oh, interesting. So it's not really hitting some of these. So for DX and DY, DI, DJ, uh, print, DI, DJ, minus 1 comma 0, 1 comma 0, 0 comma 1 equals to 1. So maybe is my valid check like maybe I'm checking this wrong or something. So if 0 is less than di is greater than or equals to 0, less than len grid, and 0 is less than or equal to dj less than.
Okay. We're pretty much at time. They're 45 minutes.
Okay. Okay.
Okay. So how's that for you? How do you think you did?
Uh, so since like I don't know, I feel like I think I got the first question right, and I think this is close to the solution. Probably like, is this close to the solution by the way? Like, is this how you do it?
Yeah, you're getting really close. You're getting
Okay, yeah.
close,
So
but
conceptually, it's sort of like the same, right? Like similar.
yeah, you're close. Yeah, you just need to play around with it a little, and it's gonna work. But
Yeah. Okay.
it's not
Yeah. So
working yet.
I'm like, like when I started, like I like completely blanked out because like I was so nervous. So like I couldn't think for a while, but like I feel like after like maybe like 5, 10 minutes, I was like, okay, you know, I was like more back to normal. But like this was like very good for me because like it was sort of like, like you're streaming this, so it's sort of high stakes in a way.
Yeah,
So it kind of stimulates that sort of like interview feeling because I was like kind of nervous waiting for this as well. So yeah, so it's probably going to be similar for the interview as well.
yeah,
So in that way, it was pretty helpful. So it's because I've been doing mocks from like this website, but it's not the same because it's more chill in that mock.
yeah.
This is like I feel like this is more realistic.
Nice.
So yeah, it was very helpful. And I think I did okay. I don't know. What do you think?
Yeah, I would say the first part my notes like you misread the question at first, and I think
Yeah.
you're
So the
having yeah you misread the question, so you were doing like validate the apprentices with
yeah
the stack, but
yeah you're right.
but like yeah you would have solved that if I gave that to you for sure because you pumped out that algo, but after you realized that you need to switch, so yeah, same thing that happened with the last candidate. He kind of thought
Yeah
it was something else and he decided to go with it right away. He misread it, so
yeah
always
exactly
think
exactly.
twice.
Yeah, you're right. Yeah, I feel like I need to like like when people say like there's like a template like you need to ask like clarifying questions and
Yeah,
then so on and
exactly.
so forth. Yeah, I feel like that's I need to follow that more. Like I have to like be like strict, especially for this and as well system design as well, because I find myself like falling into these traps. So like there's the problem solving side of it, and there's also like like time management and like like following the patterns, whatever, so on and so forth. Like learning how to like interview as well.
Yeah, exactly.
Yeah.
So yeah, follow. Yeah, that's good advice to yourself. Like just literally follow. Always clarify. Always come up with at least one clarifying question, even if it's dumb. Like, oh, do we have
Yeah.
no or something like. Even if
Yeah.
even
You're
if
right.
it's simple, it's you need to at least clarify a little bit. Um,
Hmm.
yeah, I think you need to work on your backtracking algorithm. Have you have you practiced a lot of backtracking algorithms?
Oh yeah, I've done like I feel like I've done a lot of those, but I probably need to go back in, like
Yeah.
especially in these like time pressure, like as I said, like I was so nervous, like I couldn't think properly. Yeah, I literally couldn't think at all. Like I was so what the.
Alright. Yeah, cause okay, you clutched that one eventually, but just required the hints. So
Yeah, yeah,
for the rotten oranges, yeah, I think conceptually you're there as well. Same with the first question, but getting it to actually be working code, you just didn't get to
Yeah,
for both of the questions. So
you're
this
right.
one,
Yep.
I don't know what's happening here. I think.
I think it's somewhere. It's kind of this part maybe or
Yeah, I
something.
think the code's even getting a little bit more overcomplicated. So, I mean, you should try to work this solution out on your own and just
Yeah,
memorize this
yeah,
how it's gonna look, because this is
yeah.
boilerplate BFS. So I think
You're right.
so. Basically, the last question was boilerplate backtracking. This one is boilerplate BFS. So I think
Mhm.
just you should be able to master both of these so that if they ask you a small variation, you already have the
Yeah,
boilerplate.
you're right.
But other than that, like yeah, I think definitely kick out the interview for at least a few weeks because
Yeah,
you want to get it down, and you could like just try. I would try to push it out as far as you can, like even a month,
you're right. Mm-hmm.
as long because you only get one shot, and if you miss the shot, they're gonna make you
Yeah,
interview 6 months from now or
you're
a
right.
year from now. So usually, if I have the chance and I'm not prepared, I would always just push it out
Yeah.
unless
What
they're
What do you think?
saying or go ahead.
Yeah, what do you think is the best strategy to kind of like because like do I like go by like patterns? Like do I practice patterns or like
Yeah, I would go pattern by pattern. So for
Yeah,
example, you should solve this rotting oranges. You should spend a day
yeah.
solving this rotting oranges, then solve like 5 or 6 more BFS questions like walls and gates and
Mm-hmm. Mm-hmm.
um, do number of
Mm-hmm.
islands using BFS. Just do a
Mm-hmm.
bunch. So just do pattern by pattern until you get it
Yeah.
down. So like spend a day doing backtracking. So do like just parentheses one, then combination sum, and there's so many different ones. Just so you
Yeah,
could
you're right.
see, go pattern by pattern, and then just start doing Amazon tagged.
Mm-hmm. Mm-hmm.
Yeah, you
Yeah.
need to like spend a day ironing out one pattern. But like yo,
Yeah,
you're
by the way,
almost there. You just need to do like 5 or 6 more BFS ones, and
yeah, yeah,
by like the fourth, fifth, and sixth, you should be typing it out so fast.
yeah,
That'd
exactly.
be the goal.
Yeah, I mean, like the fact is, like I've seen this problem. Like, I've worked on this problem before,
Yeah,
right? And the fact that like given like the environment, like like the time pressure and all of that, I still couldn't properly complete this means that like I need to work on it a lot more. Like even the generate parentheses, I probably worked on it
yeah. No, they're
because it
classic
seemed
questions. Yeah.
yeah, yeah, yeah.
But yeah, I only asked you these because they asked me these questions. Like it's too
Oh
specific.
really? Yeah.
I went through their process before, but this was like 4 years ago. I asked this.
Okay.
So,
Yeah.
but what I'll tell you from my interviews with them is they ask classic code questions and they like to prioritize graphs.
Mm-hmm.
Make sure in the behavioral that you're mentioning leadership principles, so have different stories for each of the
Yeah, you're right.
leadership principles, and you should
Yeah.
prepare that. And yeah, they won't make you run the code, but they're gonna ask you classic questions like this.
Mm-hmm. Yeah.
All right, man. Good luck. Let
All
me
right.
know if
Thank
you
you
need
so
to do
much.
another one. Yo, yeah, practice for like 2 weeks. Go pattern by
Yeah.
pattern and book another
Yeah.
one with me, and let's see
Yeah.
how you perform.
Okay. Yeah. Yeah. I probably want to do this like more often because I'm like that's what I do. Like I'm like practicing sort of like every day.
Yeah.
So I'll probably book it more frequently if that's okay.
Okay. Yeah. Sounds good. I'll
All right.
send you.
Thank
Yeah.
you.
Email me. Okay. Peace.
All right.
All
Thank
right.
you. Thank you.
Have a good night, man. See ya.
Thank you. You too.
Yeah. We'll get him prepped for Amazon. All right, chat. That's pretty much everything for today. Thanks for tuning in. We had some good coding interviews. We had the founder. What do y'all think about Nabil? Was he sick? I want to get more guests like that, at least one per stream, so we can get some insight into them, into how they work and what they did in the past. All right, chat. Gotta put my outro. I'll see y'all in the next stream.
This is not my main thing, really, I'm a coder. Coffee stains and name chains. I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lead code, beast mode, 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 lead code, beast mode. This is not a main thing, really I'm a coder. Coffee stains and name chains, I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over.